Now saying hello everyone, welcome to day 25. Today we'll enter week 4, so module 4 of DoubleJump Academy's workshop, Houdini for games. The link is in the description below if you're interested in that workshop. I'm personally just documenting my experience so far, which has been overly positive. Okay, so module 4, we have a mesh and curve creation. That's the very first video we will start with today. And you could see that we'll be creating some vines. I won't show you the video, of course, because that's not part of it. We'll select spawn region, so I guess this would be like a region where the vine will, generate on. It will be interesting to go through that. Then we have select spawn point. I guess we will be able to select it freely. I don't know what that means. I would say the titles of those videos need a bit of work on, but so far so good. Connect curves, good. Noise to curve. I guess we'll add some noise to them so they look random. Branching iteration, vine logic polish, growth attribute, Unreal testing. So we'll do some Unreal testing, episode 10. This will be probably 4 days of stream because we will do a lot of fixing. Vellum simulation, awesome. Unreal opacity. So I'll tell you what I have in mind for this. I want that vine to generate eventually on the bridge, and I'm not sure how to do that. So yeah, we'll see. We'll learn every episode, and then we will try to do that. I see that module 5, week 5, we'll have some Substance Painter. I don't have a license, but I'm probably gonna go with the trial thingy and see what they offer me. Okay, I've worked with Substance before, but not to the level where where I'm satisfied. I would still want to learn more and more and more. So that's awesome. We will now proceed. So I will put this down and start opening the files, and you people who are watching the recording probably don't want to see this because it's going to take some time, so I'll pause it and I'll see you in a bit. Please put this in the recording. We've been handed Substance Painter files, Unreal files, Houdini files, because it's a week 4, 5 basically, and I basically just opened our Houdini project and saved it as week 4 because I want to continue from this project basically. Okay, and now we have those files. We could check them out later. I would rather watch the videos and keep those as references, basically, as just to pull references from. Like, for example, if I don't understand one, yo, thank you for the follow, appreciate it. Art of Javi. Hey, Javi, I know who you are. Nice to have you here. Awesome. Nice to have you here. Okay, let's see. So we will have our so this is our Houdini file. These are the files they gave us. I'll pause the recording. We'll look into how to create that. And so part of that is watching a lot of tutorials and do a lot of experimenting. And so this will be the node tree that we'll be working with. That is on the part of, where's the HDA and all of that? Wait. Attribute delete DJA, that one. Should be our infection. And I don't want to go there. I just want to see here you go. These are all the parameters. We have core. It does a clean input mesh. We've done that before, if you remember. It does a growth, a thickness, a branching level, split threshold. I'm excited to do all of this with y'all in this week and next week as well. We'll have a split bias. This is going to be very interesting what it means. We have a point number 3 or position 1, value 1. We don't know yet what that all means. Micro veins. Cool. Those are, I think, the branches. This could be the micro veins. Not entirely sure. We'll see what that means in as we go. And then we have more. We have tweaks, noise, simulate. Oh my god, it's gonna be very interesting. Okay, so yeah, all of that is here. We will learn all of this as we go today. Maybe we get to cover 10% of this today. So yeah, let's work on it, people. Let's put it here, just for you to see, and basically we'll pause the recording. File. This is our main file. Let's put it on full screen. Doesn't matter. Okay, so this is our main file. We'll go out on the object level. We will hide our destruction. Call it destruction. We'll call it week, what is it called? Week 3, 4, basically. It was 3 to 4. Week 3, 4. Okay, destruction. Good. Now, bridge was week 1, 2. It's gonna load a little bit. Let's hit double escape and go back to the object. Come on now, double escape. And the bridge will be called week 1, 2. Sorry, 1, 2 and space bridge. This is how we're gonna call those. Good. And now we need another geo. And so we'll put that. Let's put this here. We need another geo. And we'll call this, we'll be busy with it when week 3? Now week 5 until week 6. And we'll call this one Vine. Vine, I'm not sure if I can add slash. We can't. Slash and basically. And is doable. None of those are doable. Week 5, 6 Vine infection. Good. Now, inside of this one, I'll make it bigger a little bit so y'all can see it. We'll create a box because we need a mesh to work with. Let me hit F. Good, it works. This box will have a draw curve like before as well. And we will need a subnet. So subnetwork, and we'll call this one again DG. Call it infection. Call it DGA. Fine, just make it a bit different. DGA infection. GJ, so for Jack Goodman, good, or Jack the Generalist, good. Let's call it like this. We will hook that box into the curve, and I think the curve into the first input. Subnetwork is nothing but a group of nodes, but now it doesn't exist, so we'll have to turn it into an HGA, and we know how to do that by right click and basically, all right, let me remember that one. It's a tough one to remember, but it shouldn't be that hard. So right click and create digital asset, help. Yeah, create digital asset should be the one, and it should save it basically. I'll go with the tutorial for now. We'll be right back with you. I kind of want to guess what is to be done here. Just so a step that I couldn't understand yet, but we'll just follow a bit blindly here. So Shift S just to make those connections a bit better. I know that we need to set up the draw curve on a projection level. So if I go to a projection here and let's view it as well. And so if I say projection, what was it? XY plane, geometry plane, and a geometry right there. So it will do the curve on the geometry itself. So this is how you do it. That's great. I was able to remember it. That's awesome. And if I hit enter in the view, we should be able to create some curves. And yeah, this will create primitives for each curve. Primitive 1, primitive 2, primitive 3, correct? Detail. What is it? Primitive. I can see it right here. If I hover over it, middle click, we should be able to see that it created 3 primitives. Or stroke, blah, blah, blah. Yeah, I mean, that's what we know so far. So I'm not going to go and check it now because we need to learn. So we'll pause. So we're approaching this whole thing a bit different than before. We know exactly what we want to do, and it seems like Grayson had a lot of time looking into that thing and organizing it, and he even mentioned that he quite enjoys to create that type of system of generation. So what we will do now, double click on the DGA and start creating our main subnetworks that we know we're going to use. So first subnetwork will be called clean mesh, so we need to clean the mesh, and I really like this approach because it makes a lot of sense for me to start like this because I know exactly what I need. So first we need to clean the mesh. Here we go. Let's hook that here and click Shift S just to have the curves a bit like my liking. So this will go right through the box that is running through the curve itself, right? No, directly. Okay. So, and then we will add a new subnetwork, and it will be called, and I have a system to do this. So I'll apply that system too. This will be called clean curve. Clean curve. I like to call the subnetworks either an OP for operation. I don't know why I like that system, but it works for me. Or if it's something that is generating something, I will call it gen in the beginning. So this is an operation clean curve. It's an operation. It's not generating any meshes. It's not generating anything. It's just an operation. So this is operation clean mesh operation clean curve. I'm not sure if this is a proper way to do things, so don't take my advice. It just makes sense for me to color them yellow, have them called operation, and the generation for me is purple. If this doesn't work for you, I totally understand. Don't worry about it. There's also Grayson's way of cleaning things is adding the null after the main subnetworks, and he calls them out and ins. So out clean curve. Just so if you missed on that, here you have it. I didn't follow it to a T because I wanted to make like my own system, but we could follow it today. It's fine. We'll connect this to here and call it out clean mesh. Yeah, let's do it like this. Good. So we've learned this so far. Just wanted to introduce the way I clean things to you. And this is a bit of a new approach to us, this type of creating the subnetworks first, knowing what to do first, and then diving into it later. If we view our infection file that they gave us from before, we see that if we go inside of the... Well, first we have some type of curve, draw curve right there, and we see a system that takes any types of mesh, and here it's a file. That's where the head comes from. If I double click on the DGA infection, we see a similar system where it goes into the cleaning operation, and it's the subnetwork clean curve. And here the same thing where it goes in mesh and in clean mesh. This is how he has his system. It works for him. It's amazing. We can also do it. We can also say in mesh. Null. Let's just organize ourselves a bit similar. So I'll call this in mesh. All right. So here we go. Because sometimes here it says box. Sometimes it might say sphere. It might say the name of the operation before it. If I may show you here. So if I add anything, delete attributes, for example, or delete, and hook it up in here, it will show delete. And we might have that operation do something, but we still want it to be called mesh. So we'll just call it in mesh right now, right? And we won't give it a color. I'll just keep it as it is. We can give a mesh a color. I don't mind that, but I just don't want it to be special. I just want it to tell me what is coming out of here instead of this box thing, right? It's gonna be called mesh, regardless of what it is going to be. It could be a head, could be a sphere, could be an ant, it could be anything. Okay, so we've learned that so far. We're doing things, we're approaching them a bit differently today or this week, and yeah, let's keep it going. Let's pause. So first of all, sooner or later we'll do that. So let's do it right now. Let's keep the box, but we'll basically add a file and we'll import some meshes. First mesh I'll import is the same mesh from before that we had on our desktop, which should be the actual mesh from Unreal, which is the huge column mesh right there. For some reason I can't press F on this one for whatever reason. And let's put the shading into flat shaded. It's funny. Where so we need to view it. Okay, we'll use this one, people, because it definitely needs a cleaning because it's quite messy, and we will use anyway something like this later. So let's hook it up in the same way we have it before. So column, and we'll hook it directly into input 1 and directly into the draw curve that goes into input 2. Okay. And now we have in mesh. We know that this in mesh is a mesh and it's not a cube or whatever. Could be anything else. And yeah, we'll be using that. Good. So what we'll do is check if our draw curve is drawing. So if I press enter here, and I draw, it draws right on top of it. Good. Let's try something more complicated like that. Is it drawing on it? Yes, it is. Let's keep that curve. Actually, I quite like that curve. Yeah, it looks amazing. Yeah, you could totally try, if you don't have an FBX on your desktop, which is something we've done, by the way, last time we were here. You could add some stuff that are already in Houdini, such as the pig head. This is pig head. Look at it, like right there. It's the pig head. If I may press F on it. Can't. All right, so here it is. I don't know why sometimes the F works and sometimes it just doesn't want to work. But yeah, regardless. Oh, dude, this is quite weird. Okay. Let's see. Do I have to select anything? Yeah. Okay. And then it pans over it. So you can have a pig head. You can have other models as well. Where's the pig, by the way? Where is it? In which test geometry? So let's look in test geometry and see what else do we have. If I tab test geometry, yeah, we have this one, which looks like this. Also a pig for some reason. Oh, no, it's actually, yeah, a beaver. That's a beaver, I think. Yeah, but it has a human body. Test geometry. We have a crag. These are cool though. Yeah, you could like totally create things out of those. Like have them crack or something. Not sure if you could animate this one, but it would be interesting if you can, because that would allow Houdini to have rigs inside of it. I'm not sure if you can, but if you can, that's awesome. Yeah, you can have different type of test geometry if you don't have that file that I'm working with right now. Shouldn't be a big deal, honestly. Okay, so we have the curve. Everything is working. Let's go into Operation Clean Mesh, and we will probably need match resize or match size right there. And this should allow it to match the size if we change those properly. So what I'll do is pause. Let's try to guess some of the steps here. We've done a clean mesh before, so it shouldn't be too hard. So what we will do is definitely go to the mesh size. We'll stash our X form like we did before and scale to fit. And now it's fitting into a more predictable scaling. So yeah, like you see, it fits the other scaling, what it's called, like scale of Houdini. It's translating it into a Houdini scale, so to speak. So it's giving it a more predictable scale. So let's see, let's select, because I need to be able to pan around this. I wish there was a way it worked before, I swear. I've had it working. I press F and it's just, oh my god, dude. All right, so let me Google that problem. We'll grab. I have experience now that it's not F, actually, it's G. I could be wrong. Okay, let's see, G. Space G, it says. All right, so space G is definitely the one. Do I need to select things, or can it just work all the time? Let's do the match size, and if I'm here, space G, we'll go back. Amazing. It will go back in the center of the world, right? Regardless of object. Okay. I mean, one way to test that is create a box, right? And take that box in the, I don't know, this axis. Uh-oh, not here. This one? Yeah. And now press shift or space G. All right, so it really focuses on the object. That's good. Space G, everybody. Use that one. Click here. You can't see it. Space G, and you should be able to see it. Okay, so what do we do after that? We convert to VDP. So VDP to polygon, VDP to polygon, something. Polygon from points, from polygon right there. Put that thing here. View it, and you will see that it's completely reliable. Well, good thing we started from here because we have our references. So if I go into this, all right, so let's expand that one actually. And now we'll be able to cheat. So let's go inside of here and go into our work from before. So I'll go to clean mesh here, operation clean mesh, exactly this one. And if I go back to destruction, exactly, and I go inside of here, We'll double escape because I don't want it to generate anything, and go to operation clean mesh. And instead of here, I'll take the values. Basically, I'll just reference the work that we've done. You can see it right there. We have a UV transfer. I think that one transferred our UV values back in because it converted it into a VDP, and it was weird after that. So let's just copy that value. Is it a 0.01? Did we do anything else? Now we see 0.1. We have 0.05 to make it accurate. Maybe we don't need it to be that accurate here because it's basically not breaking apart. So let's go with 0.01 here. And if I may show you that result, it's looking better already. And the rest is fine. We have good values. Okay, so this is what you could do after you learn things, just reference them. Then we have convert VDB, and we have a value of, yeah, the same. So let's do it, convert to VDB. Convert VDB to basically to polygon. Here we go. Is this the one? Convert VDB points, convert VDP. Now, let's look for convert again. Convert and convert VDB, this one. Not to mistaken it with points. And this one should basically now, if I click on this one and compare them. Okay, so from volume to polygon. This should allow us now to have mesh. Basically, yeah, here we go. We have a mesh. That's amazing. Man, this is so cool because in some, like in Blender, for example, you need to purchase an actual plugin and you probably need 3 hours to troubleshoot it to work. But here you just have VDB to, you know, convert VDB, and then you have a thing that works, and which is amazing. I also appreciate the UV tools in Houdini. I think they're unbeatable. So yeah, that's quite nice. Sorry, TikTok, we have lost the connection, I believe. No, everything's running. Pretty good. All right, awesome. Let's keep it going. We have our column. It has all those details. Great. Let's see, VDB, convert VDB. All right, so far so good. We were able to guess the next steps, and it is correct, I see in the tutorial. Let's pause. Basically, we haven't used any UVs here. We don't need UVs in this one because all what we need is any type of mesh to test on, and this will be our column, for example, and we need things to spread on it, right? The actual UV work will be on the vine themselves. So, or in the infection itself. Okay, so how do we do that? Let me try to think. So, here we did a UV transfer before because we needed the UV, and here we just need the scale. So we'll pull those a bit to the side, and we stashed our X form. So in order to bring it back, Shift S if you want this to be curvy like that. Get the attribute transfer. Attribute transfer right there. There we go. Let's get our X form from the details. Wait, let's hook it up first. I think from is the right one, right? This is 2, and the from is here, right? So if I hover over that input, it should tell me geometry to transfer attributes to. No, we need from. Geometry transfer attributes from. Exactly. So this is the from, and this is the to. So we want to transfer our X form to the VDB convert because it loses those values, and then just basically hook it up into the output again. We need the X form for later to scale things into consideration, or to consider the actual transform or the match size whatsoever. So what I'll do is pause. So the main problem right now, and I'm guessing what are the next steps because that's part of learning. I try to understand what the problem could be. So I'll close this one. And let me show you. So if I go a hierarchy above, we see that our main mesh was so much bigger that it was incredibly like huge, and we drew the curve on it. And if I may here like add a null just to see, just to view things, we'll call this in curve. All right, so curve C big. All right. So this is our in curve, and look how big that thing is in comparison to our matched size column. So we will take the X form value from here and hook it up in the second input in here, and we say Shift S just to see. All right, no, that's fine. Shift S just for me to see the organized version of the connections here. It's fine not to have those next to each other, so this way to see basically what is happening. I probably should not take it out from here, just stick it out from here. Anyway, so we have a better idea where it's coming from. And so this is our out clean mesh, right? It went from being unpredictable, huge, to something more predictable and has a uniform scale, so to speak, and has those clean points or clean connections to itself. It has a clean geometry as well. It's not super clean, but it can be tweaked definitely, so that's fine. It's just more unitized. So yeah, we've done that. We neutralized it. So regardless of a mesh, we will have something that works, that has equal points as well, equal geometry. So what we'll do is, now we've done that, we had an out clean mesh, and we hooked that out clean mesh with its X form into the subnetwork, which should do the clean curve operation. And if I go inside of here and I will add a null, basically, we'll call it, this is the in. So we'll call this one in attributes. Definitely attrib something. So we'll just call it in clean mesh. And clean mesh, that's fine. Let's keep the attribute for ourselves because we'll basically know what to do with them. And this will be our output. And what we'll do is that attribute transfer. And now I'll add another null just for organizational purposes. And we'll call it in curve. And yeah, that one will be here for organizational purposes. And all right, so in curve, in clean mesh. And now we need to do something with them. So we'll add an attribute transfer. And we'll do it right there. Attribute transfer. Okay, and we need to transfer from to, and now we start viewing them. We can't see anything because they are super huge, and let's hope that the actual X form will do its work. All right, it didn't do anything. That was my first guess. The second guess would be to add a match size, and check if it has two inputs. Yes, it does. So this one says geometry. All right, so let's see. If I hook this one here, geometry whose bounding box is to be match, and this one. And now we should probably do some settings in here to make it work. One of the settings that comes in mind, restore transform. But it's definitely weird. Let me see what else we could do. I am guessing, like just guessing right now. So this could be wrong what we're doing right now with the bounding thingy. We need that to be inside somewhere so it matches it. But I'm missing a thing or two, so we'll watch the tutorial, see how it's done. And just us trying this gives us the ability to say, to hit a wall and reorientate. Is that a word? Just reorient and redirect ourselves and go into the right direction, basically. Okay, good. Always fail. Progress over perfection, people. I have the answer now. I was close to it. So instead of match size, we need an attribute transfer like we did before. But that was not enough to do the actual operation. So it was correct to do from and to, and then get the detail, attribute X form, and then have a transform from, okay, transform from attributes. All right, so attribute transform basically. Transfer by attribute, here you go. And if we hook that up here and we enable it, we have it on the same size as our mesh. If I template that one and I view that one, here you go. We fixed it. That's how you do it. We were very close with our first solution. Then we hit a wall, right? Fine. Now we understand the importance of a transform by attribute now. Better than before, because before we were following it blindly. But now we understand what this thing can do. And what it does is it does the transformation by the attributes themselves. So if you just do it by the attribute transfer, it's not enough. It will do the transfer to the curve, but it won't do anything because it's not an operation. It just does the transfer. That's in its name. And then we have transform from by attributes, which should basically do the job for us. Good. So far so good. Let's pause. Now just to view what our operation is doing. It should be operation clean curve. And like we've cleaned other curves before, we need two nodes, resample and smooth. So if I smooth it first, it could give us some bad results. And by that I mean, if I go here and I go into the point count and I go into the numbers, you see how many curve numbers there are, how many points there are. And this will be not so performance friendly, I would say. One thing I noticed here is that we have two lines almost and they are not connected. And I wonder now if we had the same issue in the curve itself. So I'll do space G here. That's the clean mesh. Okay, clean in curve. Let's go. Space G. And we'll check on that point here. Yeah, it exists. Let's go a hierarchy above. Let's go all the way to the draw curve itself. And yeah, check it out. All right, so we have like this disconnect. I'm not sure what it's due to. Let's go to the curves. How many do we have? Let's press enter, stroke right there. We have number of stroke 1. And if I add another one, now we have 2. So this was a 1 stroke, but it was disconnected from each other. This could really cause some issues. So in order for this not to happen again, I might add a fuse. Let's see how that would, if it would like it, basically. So let's add a fuse. And now we'll go on the scale again into something crazy. So space G to refocus again. And let's see, let's try to connect those points, honestly. Is there a way to do it other than fuse? Oh man, I need to go to the bathroom. Oh, we were wondering if the fuse here would merge those 2 points together. However, we might need something stronger. And how are the points? Are they connected? 1, 5, what is it? 1, 9, 7, 1, 9, 8. This is where documenting your learning is very important. So what I'll do is go back to one of the very first episodes, where we check that out, basically where we've learned it. So we'll go to my channel and excuse me for promoting this. Oh, I just saw that I might not be live vertically, but yeah, we'll check that out later. Just let me check that out now. Shouldn't be a big deal. So which one is it? It should be live. We should be live there. Yeah, it is live. This is live too. Okay. It doesn't matter. We'll just keep going. So one of the things I wanted to look into is, let me check. So yeah, day 0 or day 1 basically is where we started to learn those things. So we have day 1. I'm just checking the video itself. It's right there if you're curious. We'll put some, maybe I won't put some sound. I just want to go through what we worked on. It might be day 3, honestly, not quite sure. Let's see, did we use any fuse here? Did we use any fuse here? Revolve, we worked with some revolving. Okay, so we worked on the revolve. However, I don't remember doing a lot of fusing here yet. Let's see. This was all work. Let me check here. No. And let's check day 2 then. Day 21. I love the playlist. It's like day 1. Do you want to check what happened on day 22? It's like, no. All right, so let's close this one. Go to day 2. And this is where documenting the learning helps a lot, because not only you have... All right, so we have a bend. All right, so this thing we don't need. Let's go further. Self-transform. All right, just gonna go further again. Join, that one, the join. Okay, let's go. Let's join. Let's tab and join. Just in case it needs joining, we'll join it. Here we go. That is it. That's what I wanted. So it could be that you draw a curve and then it's, you know, not joined like that. And so we will join it now. It has the same number, 196, 197, 198, and it continues. That means a fuse might not be needed. So we'll delete that one. So we have a join, and then right after the join, we will add one of the resample node, right? So what the resample does is it creates equal point distribution without losing the shape. But now it's losing the shape, so one of the main reasons we need to keep the shape and keep the equal point distribution here. And you see that, like, right here, now after the join, it's quite weird. We have 142, 141, and 143 right next to each other, and then you have 140 that jumps out there. So basically, we will make it look better and have the equal distribution of the points. The lower the number, the better it gets. So 0.5 here. Nah, that's maybe too much. 0.7, because we still need a couple of more operations on that. Yeah, this looks pretty neat. I mean, what we could do as well is have a 10 here. Oh, sorry. The TikTok live thingy wants me to confirm that I'm here and I'm not an AI. I'm not an AI, TikTok, but thank you for checking. Let's see the 3. Let's go a bit higher. Let's go with a 7. And now we will add a smooth on this. Smooth. And this should smooth our line, but I kind of wanted to smooth it. This is good, but I kind of feel like it needs to keep the shape, honestly. Yeah, something like this with... So what I also need is to keep in mind our mesh and see how that translates on the mesh itself. You see it's going through each other here, and then it's going out of it. Could be due to the join, honestly, right there. Yeah, the join definitely had destroyed some stuff. Let's see if we could change that. That's not... Wait, is it not the join? Where did the join happen? Right there. Okay. So the curve here got weird, and the resample, fine, smooth. Yeah, okay. So let's check our smooth with our clean mesh templated. All right, then let's see how we could smooth it in a way where it doesn't lose its form. And it just has to follow it approximately. Yeah, that's fine if it goes inside of it, I guess, at some point. Yeah, that's good. And then, yeah, these are a lot of points, man. So what we'll do is probably take this a bit higher, 0.01. Let's go with 0.0. Wait, the lower, the more. Okay, so how does this look? Yeah, it looks bad. So 0.5 here. All right, so 0.3. Yeah, I like those points. They're not too intense, but they're losing shape, as you can see here. Okay, let's go with something that will keep the shape. 0.02. Yeah, I mean, now wait. Okay, so we're losing a lot of shape due to the smooth. Yeah, this is better. The smooth is keeping it in order. Yeah, that's fine. It has a lot of points. Fine for me. In the workshop, they basically do this twice. Another resample, another resmooth. But I kind of want to keep it simple. I feel like this is way too many points even, but it's kind of matching the mesh density, so we'll keep it like that. And yeah, let's keep it going. We'll stop the recording here. The normal seems to be a huge important thing here, so what we'll do is check them out. I'm just curious where they're pointing at right now. Are those the normals? Display normals, yeah. So we have normals that are going with the flow or against the flow, or what's happening here? Do we even have normals here? Because what he does is he makes the normals point along. Sorry, he says orient along curve. So let's see, orient along curve. Okay, so if I put that here, it should give us now some normals. Yeah. Okay, so our normals are following the actual curve, space G. And let's see, space G is just a shortcut. I'm sorry, I don't mean anything. There's no attribute called space G. I know it sounds like an attribute, but it's just the shortcut. So I feel like, yeah, okay, we have a lot of details there. This might affect us later. We'll keep it like it is though. This is already looking great. Like as an effect, I really like this. Although it looks very spiky. Yeah, we'll see. We'll see what the next steps are, honestly. I wonder if I do a resample and smooth again, what will happen? Like on top of everything. Are we getting smoother points or less of smooth? Yeah, they're pretty smooth after this one. So we'll keep it, probably. I like how they're smoother here. Alright, so let's keep it like that. And we'll pause and go. We are like at the last 10 seconds of the first video. And we learn now that it's a good time. Oh, this looks pretty furry. It looks pretty cool. Okay. Let's do... yeah, we'll just... Nah, let's keep it like this. We'll create an HDA out of this thing. So right click, as we've learned, save, create digital asset right there. It will be called D user, whatever, DGA infection, Jack Goodman, Jack the Generalist, and 1. Let's see if this would actually work. So we'll create it. Now it gives us the properties menu, and the minimum inputs will be 2. Now we should go into our inputs and name them. 1 will be curve input. I think it's the second one, honestly. So curve input is right there, and 1 will be mesh input. So let's do it. What am I doing here? If you're asking yourself, what the heck is that? I'll show you, don't worry. Mesh input and curve input. And that's how you create an HDA. That's the step everybody don't know about, and it's just as simple as that. So curve input is right there, and mesh input is right there. And now we have 2 inputs, and this thing is, yeah, it's communicating with the column that goes into the draw curve. So it draws on the column, and then it goes into the DGA infection. Okay, so that is it for the first video. We will go into the next video. I don't mean the video, the actual YouTube video that we're having right now. I'm talking about the courses video. Good, so we watched that. We will probably have, how many do we have this module this week? 2, 3, 4, 5, all the way to 12. So that's 1 from 12. Good progress so far. Let me just watch the last seconds. There might be something there, and we'll be right back with you. So we have cleaned our curves, correct? And they look like that. And we have our normals that look like that. So what we will create now, it's probably a wrangle or a VOP that allow us to randomly pick points and branch off of them. And this will allow us now to create those branches, right? Like a vine system does normally. So we'll create those branches here and there, correct? And this will allow us to have randomization as well. So we will have parameters that give us those randomization and 1 parameter to give us growth. And that one you can see right there in the actual final file that they have provided for us. And if I may go and give you like a little display of it, let's click on the HDA they provided, and we have growth. So we probably need that. We need something to work like this. And these branches are those vines or veins now in this case. They're randomly being generated and there's some noise into them. And we'll go into that in the upcoming videos, which could be this week actually, where we create those things. Eventually what I would like it to do is have a simple animation of like the blood going through it. I don't know how to go through that. Maybe I should ask Grayson about this, or maybe he covers it even. So yeah, we'll see about that. Yeah, so this is the final file. We're working now. We're starting to, you know, create it slowly. And so the next step here is to select random points from this and allow some branching of those points in the direction of the normal, I suppose. Or we could do a calculation where it goes against it, sometimes with it, sometimes against it. And yeah, we'll see how that works. So everybody, we'll pause. One of the main steps here is to reference our points to the mesh and see if it's messy. So let's template that one. Actually, yeah, let's template it and check where it's messy, because the smoothing, as you can see here, does some type of, yeah, it goes in and out, and yeah, it's not perfect. So what we need is a node that organizes those, and it's called raycasting, the type of method, and you need a ray node for that. A ray node, if you read about it right there, it needs a collision primitive and a ray point or primitive. So I believe, let me see. Let's read about it a little bit. We can see that we can cast something, can ray cast it on an object, and it would like glue on it. Let me just read a little bit about it. We can do it live right now. That's fine. Just so we can show what goes in the process of learning Houdini. It's not as simple as following courses and doing each and every step from that course, but also it means going inside of here. If you don't understand something, go into the help. Everything is provided for you, you know. Don't be afraid to read and just read it. So ray geometry node. It's a geometry node. It's called ray. Okay, so projects one surface into another. So it projects one surface into another. Okay. Using on this page using ray example. Okay, so let's check it out. The ray operator. I love to read this part here because it tells me the general use for this. The ray operator projects rays from each point of the first input geometry. So it projects rays from each point of the first input geometry. So from the first one in the direction of its normal, perfect, and then moves the points to any geometry that ray hits from the second input. Okay, so let me show you how that works. And I don't have any idea about that. So we'll go right here and give you where the normals are going. The normals right now are super duper big, but if I go on each point, you see that it is pretty much just going out of it, and this is the data it's casting on. So it takes that normal direction and it glues the points of the curve on the normals, and this way it will keep staying on the surface. And this is amazing that Houdini actually allows us to do this. So yeah, let's do it. We will put this into the first input and put the curve into the second and view the result of that. Okay, so we don't get any proper result because we're doing project rays method. Let's read about the method. You can use this node to drape clothes over surfaces. Okay, shrink wrap. This is like basically it's doing shrink wrap modifier like Blender. Using ray, click the ray tool on the model tab. Amazing, yeah, blah blah blah. Enter, and it should gives you. I love the graphic, the infographic they're providing us as well. So we have examples. This is also very helpful for learning. because you just want to learn through those examples, will probably be worth reading. Parameters, let's see the method, honestly. Let's Control F and look for method. And here we have it, methods. Project raise, points are projected along their normals. And which method do we have now? Project raise. So points are projected along their normals until intersecting with collision geometry. And minimum distance, points are placed on the closest point on the collision geometry. This method does not use point normals. Use it to shrink wrap or project one primitive into another. So points are placed on the closest point on the collision geometry. Okay, so it treats it like a collision geometry. No more normals, just on the actual points. So let's do that. Minimum distance. And it gives us some really, really, really weird result. Maybe I have not given this the way. Maybe we should put this one here and this one here. Yeah, that's much better. Now we have a proper result, it seems. So we have definitely shrink our curve on the collision or on the points of the mesh. And if that was a different mesh, it will look also different to it. Yeah, that's amazing. We have the points right on the column. Amazing, cool. This is how you solve that problem. So we'll pause and learn some more. The recording again. Hello everyone, we're back into it. So we will add a wrangle. So attribute wrangle. And we'll start choosing random points from the actual curve here, which point will branch off. We will branch off from, and how to do that, we'll for sure use math. So stay tight, because we will do that. So one thing to also understand is Grayson briefly mentioned in the course or in the workshop right now, what is he planning to do? I will just read it down for you, and I don't know what it means yet. Just so we have an idea about like how a tech artist minds work through the problem solving. And so he says, these curves that we just created will cut through the mesh. And it will transfer the points from the selected point groups over to the mesh. So we'll have a selected point groups, and it will transfer it to the mesh, which will allow us to use those groups or selected groups to spawn curves along the mesh. What does that mean? I still don't know. It's definitely a Houdini language, secret language that I need to learn. But we note it down, right? We talked about it. Let's see what that means in a second. And as of right now, we will go into the wrangle and write some comments. The same comments he wrote in the wrangle. First comment says, create a ramp. And I have to note those down exactly in the same way they have it in the course or in the episode, so I can understand the process as well. A lot of it is just reverse engineering. So let's do that. Create a ramp from our curve. I like this way of working because it says what we need to do step by step, even though we don't know yet what type of code we will use, but it's organizing us to do that. Create a ramp from our curve to direct the chance to split, not spit. And here, same thing. Test if it's at a test if the split is greater than the defined threshold. So I have a threshold. Is this how I write threshold? Threshold without threshold. And then we'll have like a semicolon just to explain. group the qualified points. Okay, so we will allow a randomization of some sort. So create a ramp that does the randomization from our curve to direct the chance to split. We have worked with ramps before. I don't know if you remember. Just I think in day 2 we worked with a bit of ramp, but it was a VOP, a VOP, not a wrangle. But it will work the same. And my guess is that it would work same way here with this curve. Split bias, you see it right there. It has a curve. I bet this is what we will create now. It's just a bet right now. I don't know if it would be correct to 100%. I know that we'll create a ramp, and ramps are usually gradients of some sort. And then we will write a code that tests if the split is greater than the defined threshold. I guess to keep it in place, let's see, group the qualified points if it is true or if it is false, or regardless. So we will see. We'll pause right now and squeeze our brain to understand what the vex code is meant, or how to logically build it up. And yeah, we'll be right back with y'all. Okay, there are a lot of things that we need to prepare to make the code more understandable. Just one more time, we'll go over it. So we'll create a ramp from our curve to direct the chance to split. So the ramp will allow us to create the chance to split. And then we will test if the split is greater than the defined threshold, which then, if that's true, then we'll have to group it as we'll have to group the qualified points. We don't know yet completely what that means, but those are the two comments that should structure our code and our logic. But we need some type of visualization and some attributes to make it to visualize it a bit better. One way to do it, we need something called curve view, which comes right from the resampler. So if I go into the clean curve and then go down, click on the resample here, allow it basically, hi Alex, how's it going? Allow it to basically give us the curve view right there. And this will allow us now to visualize things a bit better. How? Well, I'm glad you asked. If I add a color, and in the color here, instead of going with the constant, we'll go with the ramp from attributes right there. So we have, it goes from black to white. I will change the color just for our visualization from red to blue. Maybe a darker blue. Good. So it will go right from red into the blue, and it will follow our attribute that we got from the curve view. Curve U right there. And this would basically now allow us to see, if I just view that one right now, you see it's giving the 0 point. Well, what it's doing is it's reading the curve view. What is the curve view? If I go now into our attributes, and we see we have a lot of them. We have a CD, we have a curve view right there, we have an NX, an NY, an NZ, then we have a stroke angle, a stroke deer 2, deer 3, stroke hit. Okay, so what we'll do is delete those attributes. So we'll do a clean operation, and we'll clean it right from here before it enters anything else. This clean will just remove attributes right there. Okay, and this should clean it, because before it was basically this, all of the stuff that we will not use. Usually you would use it for other stuff, but right now we're not using them. So we're back to position. And here we should have a bit more like curve view and some normals and up value. Okay, and this color should now give us the ability to visualize our curve view. And the reason I added the clean, just so we have a cleaner slider here with not too many attributes. So here we see it, curve 0, right? The 0 point is 0 and the last point is 1, and it's making it blue right there. Great, so we are able to visualize that. Why do we need that? We will see. We'll hook that up here, I suppose. And damn, I have to go to the bathroom again. So I'll pause. Let's get into it, people. Let's start coding. Okay. So create a ramp. So we need to initiate some values to create a ramp from our curve, this curve, to direct the chance to splits. Okay, so we will able to create a ramp that enables us to direct that ability to split. And so we need to start creating those values. So one will be called float. It's a float, like it's a 0.1, 0.2. It can do all those things. We'll call it ramp. I like to call my stuff with a big letter in the beginning. You can call it whatever you want. We'll call it ramp possibility, or POS. And we'll equal it to the actual curve view. So it's the same value like the curve view, which adds a 0 to 1 float value through the points. And we're using it right now to visualize through the color. And we'll add another value. We'll call it float. It's also a float value, so we'll call it split bias. And it will be a ramp. And what does that mean? You will see now. It will be a curve, so to speak, like we saw in the main file. How to add that? Well, the way you could add it, it's called ch ramp, which calls out a ramp channel. So ch ramp right there, ramp. And then you add it between two columns right there. Actually right before that, so you need them right there, and it should tell you now basically approximately what to do. I always don't know where to put the stuff. Alex, I'll be right back with you. I'm just trying to focus here. So evaluate a ramp parameter and return its value. Okay, and the way to structure it is string channel and float ramp position. If you want a float what's called ramp channel, you do that. If you want a float ramp channel with a float time, that's very interesting. This is for visual effects. And you have the vector way to do it as well. Okay, so float, we need the first one. Float channel ramp with a string channel, which means that what the heck is the name of that channel? We'll call it split bias, so between quote on, basically quote on quote end quote, split bias. So this will be our split bias. It's the name. Nothing here is code other than just naming it right now. And we will take the ramp position that we created before as a value here, this one, and we put it right there, and we add a semicolon at the end, which should basically now give us the option, if we click on this, to have our split bias that we just called right there, split bias. And the type is channel ramp, and it's giving us this curve. And with this, we're basically enabling where the splits are most likely to happen. More on that, of course. The functionality of this is not yet there. So we will keep learning, and we'll be right back with you a little bit before I forget what it means. So the way this reads right now, in the beginning of our curve, which is the point 0, which is assigned right now, and we see it even visually, it's assigned the red color, which means 0, and the blue color, which means 1. Right here, until right, basically this here has 0 chance to split. That's what we're trying to achieve here. And this one has 100% to split. What we could do is basically add more values. Say in the beginning, you have 100% chance to split. Wait a second. That's the first one. I think the value right there. So we could say something like, in the beginning, it has 100% to split, chance to split. This is, for example, if you want to create a tree, you do the same thing. A tree doesn't split off, doesn't branch off in the beginning. It has more value of like this, so the value 0, and here maybe 0 or like a little bit of a chance to split, and then at the end it just splits all the time, right? All over the place. That is what we're trying to do. We're trying to make a logic here that says use the curve view logic that we are visualizing here and use the ability to control it with a channel, with a ramp channel, which is this thing. And this gives us the ability now to control how this is gonna split. Amazing. Good. You might need a system that splits all over the place with no chance, or that in the beginning is 100% chance and then in the middle it goes into 50% chance. Depending on the look you're going for. But yeah, that is amazing that we could actually control it. Let's see what comes next. Do that a bit differently. So we'll create an attribute. We'll call it... Actually, let's create our attributes a bit further from here. We'll create a new attribute. We'll call it f@, so it's a float, and we'll call it split chance. And that split chance is like a random chance that we need. So right now we created that variable, fine, or that attribute, which we should be able to see if we hit on attribute triangle right there, right here, and view our attributes. Wait a second. Excuse me. Wait a second. Let's take that out then. Put it right in. Put it right. We forgot a semicolon here. That's why this thing is acting out. Okay. Let's add a new attribute called f@split chance. This split chance will be it will basically equal a random value. So add rand right there, random, this one. Actually, you could just add it with rand like this and open the column or the bracket. And now you see different values. One that works with floats, other works with different things. So for example, here it says float random and float seed. So you could add a seed and we could make that seed dynamic. So for example, like the point number, ptnum, we can add, we have to say add ptnum, and this would basically now give it a value, give this thing a random number on each point number, which will allow the split chance to work randomly. So this is what we created. If I go into the attributes here, we could see that our split chance has just random numbers, as you can see. Sometimes it's 0.8, sometimes it's 0.1, sometimes it's 0.6, etc., etc. We'll probably not use it as an attribute though. We'll keep it as an attribute right now. We'll use it like this, by the way. But we'll keep it as an attribute to visualize it. But yeah, we have to change it later so it works with the logic. All right, so pause. I kind of didn't know that this is how it works, but I'm going to show it to you. I'm going to visualize it for you. So if both of our split biases are on 1, the split chance here will be higher generally on all the points. And you will have less points that have 0 in all of them. Actually, it's not working completely. But the whole point is if this was on 0 and this one too on 0, we should have less chance of that working. But we didn't hook them up yet. I wonder how that works. Ah, wait, we have to add some logic. I was thinking like, how would that work without some logic? So yeah, let's do it. We'll multiply it or plus it. Multiplying makes a lot of sense. So we'll multiply the whole thing with our split. What is it called? Split bias? Is that what we called it? Split bias. Yeah, and now it should basically work. If I click away and click back again, split chance is 0 right now because both of those values are 0. But if I put this on 1 and this one on 1, you see now the early points have bigger chance to split with 0.4 basically, and the rest has a less chance to split. But this one is a funny one, 136. Oh no, it's not. Or is it? It's a funny one, yeah, 4.8. That's very funny. Very funny number. Anyway, I know it's like -5. Whoa, E -5. That's like has the really the least chance to split, I think. But yeah, if we make both on 1, we will change those values again. So we see the 0.9s, the 0.7s, the 0.5s of them being able to split. So what we're doing is we're picking random point numbers, we're assigning random values on it, and we're calling it split chance, and we are multiplying with our channel ramp right there. It's still not doing anything, but the logic is being established basically. So let me pause and I will okay, that's an interesting ad. In order to visualize our split chance what's happening right now, we can add like another line of code here. Let's say CD, which is the color, equals the split chance. So this will allow us now to see visually. All right, semicolon at the end, not forget that. Okay, and now this should basically allow us to see the color, if I'm not mistaken. Probably called the wrong CD. Probably it's enormously important to get the spelling correct. And C here big. Okay, let's see if that worked. Yeah. You see that we have a lot of a crazy chance of splitting because both of them are on 1 or 100%. If I put this on 0, we see that we have a less percentage here for it, less chance for it to split. If I make another one here on 0, even the less chance for it to split, which will give us a longer, yeah, like here. These are able to split, the white ones, and the black ones are no splitting. So this is just to visualize it, which looks pretty cool. Let's pause and learn some more out. It's pretty cool. We'll make this logic now work finally. So what we will do is, like it says here in the comment, we will test if the split is greater, and the split here, the split chance, let me just name it correctly. If the split chance is greater than the defined threshold, which we'll have to define still, then group the qualified points. So let's do that right here actually. And we'll start with an if, just a normal if, and then we'll add the information here. So if the split chance, let's put the proper punctuations here, split chance is greater than, where's the greater? Whoop, 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 whoop. Where is the greater? I forgot. This way, yeah. Is greater than, and now we will add a new channel, and that channel is called CHF, or a flow channel, which will be a bar. See ya later, Alex. Thanks for dropping by. A bar like that, CHF, will be basically, yeah, a bar that goes from 0.01 like or whatever to 1. And we will call that 1. Let's put it between brackets, and we'll call it threshold, because this is what we established with our comment up there, threshold, which a comment does not equal code. It just means logic for us human beings. So if the split chance is greater than the channel float threshold, and we need 2 columns here, and then we'll start with the sorry, not columns, brackets, and we'll start with the other brackets, which I still don't know what they're called. And these brackets say basically in this language, then what? Then basically group, because that's what we said. So tab I for integer, group because it's either true or false, group equals, all right, now we need to give it a name, group, how to add the names to the group. All right, so group spawn points right there. All right, so I like to keep my punctuations all big at the beginning. So group spawn points. Hi Robin, how's it going? I'm doing good. We're learning some vex, and we trying to understand the logic of that, and we'll make it a true, and we'll add a semicolon at the end. That will be the only semicolon, right? Looks good. Okay, so this should have created now a group for us, and the group is called spawn points. It has 100 points in it. Why does it have 100 points, you're asking? Well, let's check here. How many points do we have? 139. The reason it has 100 points, which is almost all of them, minus 39 of them, is because, and if I click on this, we should see our threshold. Our threshold is on 0. So now it's calculating, is my split chance bigger than 0? Of course it is, right? But if I put this on 0.5, our threshold now will be at 12 points. So this will be the 12 points where it will spawn from. So far, what we created, and I will go through each one of them, created a float. We called it a ramp position, and we gave it the same value like the curve u. What is the curve u? A curve u gives a value, a float value from 0.00000 to the 0 point, and to the 1 point it gives 1, and the point before the 1 it gives like 0.09998 whatever, right? And so we made our ramp position into a float, which we called ramp position. So this step here is just to create a value that works for our logic, so we don't have to call out curve u. We just have it for us to make sense. Then basically we've added we've introduced a new variable. It's called split bias, and it equals to a channel ramp, or a ramp channel, which has the split bias, which is our current split bias, and the ramp position. This way, it will give the value of, will basically work as a channel ramp right there. It's called split bias, and it will be our ramp position. We could have basically cut all this crap here and just added add curve u, but just for our own understanding, we made it this way. We made it a bit longer. Okay, next stop is we added an attribute. It's a float attribute called split chance. Split chance has equal random point number. So it's a float value, and it just adds a random number and a random float number, calls it split chance, and puts it on the point numbers. And we've multiplied it with the split bias. That means if it's on 0, it will be 0. There will be no chance. And we visualized it with the CD here, because we said the color ID equals to split chance, which is right there. And so this way, we're able to color the split chance with white, where it could split, and with black, where it won't split. And then we've added the new functionality, which is the if functionality. It says, yo, if the split chance is bigger than the channel float threshold, which is now on 0.5, we could control it wherever we want, then create the group spawn points. And right now we have a bit more than 12, which will be 19 here, which is amazing. That means it's eliminating every point that basically is on 0.4. which is giving us only 19 points to work with, which will create 19 branches, so to speak. The less this is, the more there will be. So 100 branches, and the more this will be, the more chances there will be less branches. Okay. Robin asks if we're making electricity. No, we are actually, the main goal is to create this here, create those veins and disinfection, or we might create some vines, so something that splits out like vines. I really like this, so we'll continue procedural generating this thing, and from the logic we will create a vine as well to make it spawn on the actual bridge. Okay, let's see how we could do that, and let's go step by step and learn some more. So this is our code for now, and it looks amazing. So let's pause. And okay, so in the course they add a functionality that I didn't quite understand, which is basically right there. He basically adds my 1 minus to the channel threshold, and this should basically say if the split chance is bigger than 1 minus that channel reference, which will be always in the minus values. I don't get it quite, honestly. Like, how many points do we have in our group now? 16 points. Ah, wait, we need to save it. And basically just click away and click again. And now check it. It has 21 points. And so if I have this threshold on 1, it would have 100 points. On 0.1, it would have 3 points. So what we're doing basically is just having a general bar or a channel here that when it's on low, it will have less chances regardless. And more will have more chances regardless of the actual connection between the points and their random number. And now it's basically just taking everything and adding 1 minus. So if it was on 1, I'm just trying to understand how the logic here is working. 1 minus the channel threshold, which will make it a 0 in this case. But why are we still getting any points here? Let's see. I don't quite get it, honestly, but it is working in that way. I just don't get how that is working right now, but it is working. So if we do something crazy like add a point here, add a point here, make this a 1, make this one a 1, and this one a 0, it should basically work. Where it would have 26 points now because the threshold is very low. And if it was a 1, it will take everything with it. Yeah, it is doing exactly that. Okay, so yeah, this would work. It's more dynamic this way, but I don't know why it's working with the 1 minus. I don't quite get it because if you add a 1 minus, it would go even less with the threshold, if I'm not mistaken. But yeah, I could be wrong. I don't know why the 1 minus have created this effect. It just did, but that's fine. Let's pause. Let's see. Let's taste the fruits of our labor, so to speak. I'm just gonna put the camera back here. And what we will do is blast. All right, so blasting should blast the group and should delete the group of spawn points, which will give us that type of line. Let's definitely put our threshold to something more to see it happening in reality as well. Let's have our points here. You can see we have way less points now. And if I take that number lower, we should have even less, even more. Oh, wait, now we have more points? Wait, what? Ah, wait, let's delete everything but, which should add a exclamation mark here. Yeah, now we're working. Now it's working, good. The next thing we want to do is not to have them connected. And one way to do it is we learned in the day 1, if you add an add and you basically just delete geometry but keep the points, should give us the result that it just kept the points and it had disconnected them from each other. And here we see the number of points we're working with, which is 14, and our group is saying 15, which is good. 14 is with the 0. 0, 1, 2, until 14 is 15 points. Good stuff. This is going into the right direction, and if I basically add our threshold upwards, it has more points. Lower points. Amazing. This thing is working, and now we need a method to extract lines from this from these points. I would require the less points. This would work better, and we could also change our shape here to take this out, yeah, and have only points at the end of it. Wait a second. I mean, yeah, it's fine. Let's add more and put this up. By the way, if you click here and click on this point, amazing. Yeah, now you have it. And the threshold, we could add more or less points. And now I'm viewing the add only. Good. This thing is working, looking pretty well. I'll go to the bathroom, so a little break, and we'll be right back with you. So, we could randomize our randomization by adding a seed, and better so have it basically controlled by the wrangle, or eventually by the parameters that we want to add to it. So if I go to the attribute wrangle right there, and we go right after the rand at pitnum, and now here we could add some math. So let's multiply it by channel I for channel integer basically, and we will call this one well, how to say, exceed, or yeah, random seed, like just call it seed. And basically this will add yeah, here we go, the seed, and we could put it seed 1, seed 2, seed, yeah, but 0 will of course eliminate it immediately because it will multiply it by 0. Yeah, so maybe there's a way to remove the 0 value here, but for now it's fine. We could fix it with the parameters, but yeah, you can see that it's adding some randomization to it, which is awesome. It's amazing how like one line, not even a line of code, just like if you know where to put it exactly, you're giving it functionality on the go. So Vex is literally worth learning, and I'm really excited to learn more about it. So as we go, for now, I'm gonna pause this. So whatever the reason is, we will figure it out later, but I will show you a way to split our mesh from the points here, because we have rayed them over each other. So let's see, if I go with the split, what type of nodes do we get? We need the poly split, this one. So if we hook that one on the left, I think, and this one on the right, we should have the way this should be. Let's remove the numbers and add the points again. We should have those points now on the column. The only issue with this method is if we had 2 columns, for example, we can't really have that ability to split, because it will error. It will give us an error. So the way to fix this is through connectivity and through for each connected pieces. So let's create a subnetwork. What is it called? Flags, actions, and a collapse to subnet. And this we will call operation, because it's an operation. Operation split each piece. Each piece. Yeah, I think that's more describing what it's doing, and it will be yellow. And yeah, so basically we'll go inside of here. Now we have, let's click Shift S as well. This here is our clean mesh, and this is our ray. Yeah, and now instead of here, we'll just add for each connected pieces right there. Just apply it in here. Take that thing is inside, and let's see what we could do with this. I think so far so good. Let's take that thing, enable it here, and see how this works as we keep going. All right, so pause, learn. We'll be right back. So as we've learned with our for each connected pieces before, is that sometimes we need to compile it, otherwise it will be quite the calculation, so to speak. Okay, so how to do that? Well, one way to do it is compile. So let's add a compile block right there. Block begin. I mean, just have a compile block right there. Okay. Now we need to connect the pieces. So this goes, all right, one by one. This goes here, logically. Then Alt and drag, and this one goes in here. And we will get a lot of errors right now, but we'll just go with it. This one will go here, and now we have our block. But the problem is, a compile won't work right. It won't just go inside of an input like this, as we see here. It has to go through this type of node, which is the for each begin. We've learned that one way to create it is create meta import node, and this will create our meta import node. Now, but we just can't just, connect it like that. We need some settings here to be done. Now, let's save before it crashes, just in case. Make an incremental save here, 0.1. Amazing. Let's save that one too. And now if I put our for each begin and I change its instead of fetch, what is it called? Extract piece or point, we'll call it fetch input, just like the other one here. It's fetching an input. Same here. We'll make it fetch an input and put the thing in here. And that should basically now, well, I'm not sure now if I did the correct one. So I'll go Control Z a little bit. Let's do that again because I'm not sure if I did the right one. So this was extract piece or point. Let's keep it like this. Let's right click on this thing. Actually, let's create a meta right there and change it to fetch input. And now hook it up here. And now we have a proper compile block that should basically work regardless. Here we go. And we have an output right there. So what is this doing is it's splitting it's splitting the curve that came right after the ray from the mesh, and it's putting it in that way that it is inside of the mesh. As I said in the beginning of this, I don't know why is or for what is this used for, so we'll go with it for now. I try to understand the logic and the functionality of the things, yeah, and see what we can do later. All right, so for now, we're gonna pause. One more thing we forgot about our compiler, which is something we had to do. We did as well before. Let's enable what is it called? Okay, so let's click on it. Fall back to traditional cook if a compile breaks, force compile, always use node, enable compiling. I'm not getting that option, funny enough. Okay, we'll be right back. It's not in the compile, but it's in here, and we should enable the multi-thread when compiled, and this should make it faster. Okay, we know that now. We'll go right back into learning, so let's go. Let's see how that would work now for us. Okay, so we created that system. It's an operation that cleans or that splits the pieces. Let's put this ray in the middle here so we could see what is happening where and how. Let's put those things together because let's put them here. It's fine. Let's take the output down. And now, instead of grouping things together or merging them, we'll add an attribute transfer. Right there, attribute transfer. And if I hook this in the add, so it will transfer the points from to, and if we view it, we should be able to do this. Actually, not attribute transfer, excuse me, it will be group transfer. Group transfer, here we go. We'll put this one here and this one there. And now we see a weird looking thing. So one thing we'll first start with is the group name conflict, and we see right now it's on skip group. Parameter, we find methods to resolve destination group name conflict. So instead of skip group, we will override it, and we will disable edge groups and primitive groups because we did not work with those, and we just add our spawn points from the group after the wrangle. And now we should be able to play with this threshold basically and see where our points are. The points that we will spawn from. And if I put this on something like 0, 0, 1, we should have the actual points, but right now it's doing some weird stuff. Basically in the course they tell us that the ray should be our input instead of out clean curve here. So if I put everything down from here to have a bit more space. I definitely delete that connection and I take the ray out of here. And now we should be able to have a bit more stable result with our grouping, basically. So here we go. Yeah, this looks better. Yeah. Okay, now we're actually having the points that we need to work with, not from the out clean, but actually from the ray right after here. Let's go with 0.01. And now we should have the actual points selected. Right, so if I go here into this add, these are our points. And how many did we select so far? Okay, let's check the actual value from the course and we'll be right back with y'all. Let's check it out. So here we're getting 17 points, and in the group we are getting, how to check this out smarter, in a smarter way. Man, I can barely see, honestly, with all those points. We have like 1, 2. What if it was a 0.05? But I don't want all those points, so I mean that is already a problem, right? Because okay, so let's reference it. Let's go here. We have 1, 2, 3 instead of having 1 point, which is right there. It's a point. It's not 3 points, and so this is already a problem. And to solve that problem, we go into our operation split each piece. We go into our poly split, and we can increase the tolerance here, basically in the negative. So negative 0.6, we can see that the points are going more into each other, and the output looks more accurate. So let's check that out into the group transfer. And let's go with that lower value, 0.003. A lower one, 0.002. That looks good. And now the add in comparison is pretty accurate, I would say. Yeah, it's translating it accurately. That's perfect basically. Good. I'm not sure if those are 14 points. Right now, here we're getting a lot of points. Maybe we'll go with a 0.001. Yeah, that's better. Instead of having 3 to 4 points together. Okay, let's check what to do next. So I'll pause and learn some more and share some knowledge with y'all. Okay. I was also wondering, why are we getting so less points generally? So let's go with something in our attribute wrangle here, and definitely have more threshold, which should allow us to have more points, correct? Yeah, which allows to have the group transfer to to have more points here. Okay, that's pretty good. Yeah, that's kind of the thing that I wanted to do. So we have 64 points to work with. That's pretty good. And it's not anymore choosing 3 points or 4 points together, or even ignoring some in some cases. That's good. Let's pause. So, people, we were on a lunch break now. Not a big deal. We didn't lose too much track, but here we go. So, one of the things that we want to achieve is that those points that we have calculated here, we got from our Vex code after we blasted and basically deleted the connection, and we did our operation split each pieces, or each piece, we have ended up with those points that are accurate to the split itself. Sorry, to the curve itself. And what we will do with those points is eventually make them calculate a new route. What do I mean by that? So for example, you have the point here. This point we wanted to reach here or there or whatever randomly and create a path for itself. And this one to create a path for itself. And we want a way to randomize that stuff and make it look procedural. So yeah, This is pretty cool until now. Let's jump into the next episode. By the way, we completed that episode successfully. So we have completed 2 things. Or 2 videos, 2 episodes. Amazing. And now we will jump into the spawn region, which will be this thing that we just mentioned. And we will put it together and hopefully get done with it today. The video is 30 minutes long, so this one will be quite informative video. So yeah, let's jump right into it, people. This will be a very Vex heavy episode, so we might have to cut this. We either finish it today or we can finish it tomorrow. But regardless, we need to finish it. So what will happen now is I'll delete this connection, keep the output in the middle, and add a new wrangle. So the wrangle is where all the code happens. So here we go. And now the same thing we will do that worked for us, comments, and start basically breaking down our code, how it's going to be, what are we going to do with our own understanding. So pseudocode, that's what Grayson says in the workshop. So first line will be about set the minimum and maximum search distance. Yeah. The next comment will be, so before we go into the next comment, this line here, or lines of codes that we will build in here, should set the minimum and maximum of the search distance. That means some of them will go big, some of them will be small. If I go into the example, you see some of them are reaching quite a lot. If I go here, yeah, this one is reaching quite a lot. Some of them just barely go out of the point and reach just fairly like shortly here. For example, this one, this is well short. Okay. So this sets that minimum and maximum. Nothing yet works here because that is the plan for now. We're structuring our code with comments. We're not adding a code. These are comments. That's why they begin with a // All right. The next step is that we want to remove points that are less than the minimum distance. So we need to remove, and not remove, but remove points that are less than the minimum distance. I still can't fathom the fact, or I can't understand it fully, what this will do. So far I understand it will remove points that are less than the minimum distance. I wonder why or how would this help us? Okay, now another one. Is aligned close enough question mark, or and basically and is within is it within the right distance? All right, so this is good so far. Let's see what those 2 questions are asking. Is aligned, right? Is aligned close enough? And is it within the right distance? We will see that and configure it later and see how it works with everything else. Yeah, let's keep equal distance between all of them, especially if we don't understand them yet. Okay, color points to visualize. Good. Next line of comment for the code will be generate a random value. Generate random value. Good. Yeah, this will be easy to generate the random value. The color thing we've covered before, so this will be fine so far. The only things that we don't understand are those 3 lines here. We don't get those yet, but we will get to create them together. So that's the beauty part of this. So yeah, we'll jump right into it. I kind of need to give the wrangle a color. And the color I want to give is green because green is calculation for me. And that could match everything else. Good. That wrangle had established logic of random. So this does. All right, so I'm going to call it wrangle. And what it did is it calculated or randomized selection. Yeah, that's what it did. Controlled randomized. Basically, that's what it does. Because we can able control it. Controlled randomized selection. I won't add a wrangle because the wrangle is right there. And this one is supposed to calculate the way. So we'll call it way. And we could say, or path even. Path finding. Okay, we have a space between things. Path finding. Let's see. And branch path finding right there. Awesome. So yeah, we have a branch. That's hard to say. Branch path finding. And that one we established already. So all what we need now is to establish this code. We have the comments that should guide us somewhere, but we don't have the basic understanding of effects. But we could break down a code that's been handed to us. That's pretty good. That's good enough for now. There's more to learn. Oh, Vex definitely. But yeah, let's check it out. Oh, excuse me. Let's check it out. One thing we need to understand, and by the way, it seems to me that the range that we will create here is so random that at one point this thing will go all over the place to search, and we will create a mechanism that deletes whatever is not in the range. So my current understanding of this, I'll make a screenshot. I hope this is correct. This might not be correct, people. Don't get my videos as a tutorial. My videos are me documenting my learning. So stay with me. Let's try to learn this. So I think what we will do first, say this is our point, and our range will be this, for example. And we can control that with like a what's it called? A channel or a float, whatever, like a float value. Right? So we can make it bigger if we want to, or smaller if we want to. I'm just gonna visualize here, and we'll basically correct it as we go. So yeah, this we could make it bigger or even smaller. This will be our search distance. I'm not sure if it will be a circle, but my current understanding, it will be a circle. Then we need a mechanism to, either with noise or whatever, to basically cut some pieces out. Right, and then with a direction, so if we cut pieces like this, for example, then we could determine that our path would be this way, or this way, or this way, or this way, maybe from the normals or whatever. But for now, I'll just keep my understanding for this thing like this. So we have a path finding as that, and then somehow or the other we will have we'll have it go this way. All right. So we need the mechanism to delete the possibilities of the points and stick to the distance. So here. So basically whatever comes after that just gets deleted. It doesn't do it. So it needs a way to communicate that and a way to delete those points. Okay, so let's see how that's done. We definitely seems to need the normals, and the normals have been deleted after the group transfer. And if I enable the normals, they should be still here. Let me check. Let's add a null. Put that null here. And check our null. All right, so the normals are here. However, the normals from these are not here, I think. Let's add a null here. And check, yeah, those normals are not showing up at the end, and we need a way to transfer them. And the way to do it is the usual transfer. So transfer here, transfer attribute, basically. Attribute transfer. Then we will add the from to the to. And we'll continue here, basically. Fine. Delete that connection, put it here. And let's transfer our... It's not a primitive, is it? The normal? Yeah, right there. Let's disable this and have it only happen on the spawn points. What else is there to do here? I must have missed something so far. I mean, we could keep this enabled, doesn't matter. Sorry, not here, not in the source group, but destination should be the spawn points right there. Okay, and both of them needs to be points. Okay, and let's see that. And here we have our normal. Pretty good. Perfect. And yeah, this will go into the wrangle, and we should be able to create more code later. So far so good. Let's learn some more. So I'll pause the recording and we'll be right back. So basically, if you're wondering, yo, where are the normals from the mesh and do we need it? And the answer is yes. So the way to add it back again, bring back the normal node, or just add a normal node, connect it. First, we're working with, let's see. We're working with points. And let's view the results. Yeah, we have the colliding normal off the curve as well. That's perfect. So yeah, we have it on the points only. Seems to be working. Let's look at, let's hide our normal view. We should have weird artifacts where we have our points. One last thing. Let's have it work on the spawn, everything but the spawn points, so we don't need new normals there. This should basically now give it the normals it had before. Yeah, we could see it from far even. Perfect. And yeah, we should have some artifacts basically, or that's at least how he has it. But I think our, yeah, here we go. That's an artifact right there. That is happening because the normal is pointing somewhere else. And if I make it smooth shaded, I suppose, yeah, that's where it happens. Smooth shaded, you could see those points because their normals are facing somewhere else. And this will basically not work so nicely with the smooth shading. But that is not the purpose of this. We will eventually bring the mesh back. We just need to do the calculations here, and we need to do them thoroughly. Yeah, that's how it looks like from far. It looks like it's been cracked or something, but it's only the normals that are facing the other way around. So what did we do so far? Well, in general, all what we've done, and allow me to put this behind the wrangle. All what we've done is we realized that the normals from this one, from our curve, has not been transferred after we've done the group transfer. So we needed a way to transfer them back, and I have to click it on here so we can't see it anymore. So we needed a way to transfer those normals back, so we added an attribute transfer, and we have changed them to points because it's important. It won't work with primitives. Then we have added our destination group to our spawn points group, so it only affects them. But the downside of that, also we established here that we put the n, nothing else to transfer otherwise. I'll probably not use the primitives here just in case, although we might need the primitives because it's a curve. And then we needed our normals back, so we added a normal node that basically generates normals on everything else but the spawn points. And we did the group type to points because it's not a primitive group, it's just a point group. And to know what type of group it is, go over here and you will see point groups, spawn points. That's why we had to change things to points. Yeah, so in order to find it. So far so good. Then we have our wrangle that we need to establish, and we will do that just now, hopefully. All right, so pause. So like before, we create new variables, and yeah, we created a float value, for example. We can create now a float value that says, that, like you say, set minimum and maximum search distance. Let's call it min search distance like this. And let's do another one, call it float. Max search distance. You can call it whatever you want. You can put your name in that one as well. But just for sake of clarity, we need to tell it what does it equal. What is that variable? What does it equal? And it's not a floor, it's a float. Okay, so it equals a CHF, which means channel float. We've seen that one before. And we'll just make it, we will call that channel float also minimum search distance. And the other one would need a semicolon as well. Let's copy that value. Put it right there, and instead of minimum, we have maximum. So MAX. Good. What does that do? Well, it gives us this ability here. Minimum search distance right there. We can probably have a space. I'm not sure. If we do, then that's amazing. Well, it doesn't seem to like the space. Maybe something like this might work. All right, so yeah, now it's creating it twice for us. Let me see back here. That's why we need to call it the same name, otherwise it will think it's something else. Okay, so yeah, let's do it. And close and open. Okay, let's see. Close, open. Can we restart that thing? No. Okay, so what we'll do is copy the we will copy the vex, add a new wrangle. I don't know why it's not working. Let's see if that would work. If I do it here, paste. Yeah, okay, that is working. We can copy the name and give it the same color and delete it. So boom, inside of here. I don't know why it was. It must be a bug. Fine for now. It's not a big deal. Let's definitely learn some more. So the next thing we will work with is something that establishes the search. And that is something we haven't done before. It's called PC find. So PC find right there. And put the column, the bracket, and let's read about it a little bit. It says PC find should return a list of closest point from a file, but it needs quite the work to hook. So usage, it says, if you can start in many ways. You can start with a int, and you see those brackets like this. Those are lists. They establish that you're using a list. You could use it with an integer. You could use it with a float. Wait, you can use it only with integers, it seems. Yeah. Okay. The first one, it says in the usage, I don't know if you can follow, integer and list, PC find, then the first thing comes the geometry. Where is the geometry coming from? From which input? Is it the 0 input? Is it the 1 input? Is it the -1? Etc. We walked through this before. We'll use the 0 in this case because we will be working locally. Then the next thing it needs is a string channel or string p channel. So which location are you using it from? And we will use the p because we're currently working with the current position. Or that would be an attribute. I'm not so sure about that one. The vector p would be which vector are we looking through, and we'll use the p for position. Then we have the float radius, which would be, oh hey, thank you for the follow, appreciate it. The float radius would be, let me try to think about it. Float radius will be our minimum search distance or the maximum search distance. In this case, I think it would be the maximum search distance and an integer max point. So here we'll use our add pitnum because it will be searching through all the numbers of point or all the point numbers in this mesh. Okay, let's do it then. So we already know that it needs an integer. So what I'll do is create a new attribute, call it iAdd, and we'll call it any name we'll feel like it. But first we need to establish that it's a list. And we do that before the at right there. So it's a list, it's an integer list of, we'll call it at PTS, just because we can call it PTS for now, point search, I guess. Yeah, point search. Let's add it there. Points, I mean, the less of you know, alphabets you use, the better the view will be in the spreadsheet. So if you know the PTS is point search, good for you. PC find, and then in the PC find you will start, well, first we need the equal point. Equals, so the PTS, the integer list at PTS equals PC find, and now we'll start configuring this thing. First thing is, as we said, the geometry, which geometry we want to get, which is the local one. Because you need a geometry in order to find points, and then we will add P here for our thing that we want to call it, so to speak. And then we will add the at P for the position, because for the, what did they call it? Vector P, I think, which position it should calculate from, and we want the local position of the point. So, and then we'll add our max, what do you call it? Max search. Here we are. Let's just copy it from here. Guess I misspelled something. Just copy this value here. Should be our max search distance. So let's put it here. And Control V, good. Then the next will be our point number, because we want the thing to go through the whole mesh to calculate. Wait, it's called num-pt, right? Number points. Num-pt, yeah. Good. That is a variable that comes with Houdini. Okay. Or an attribute that comes with Houdini. Okay, so far we have established an integer called at PTS. This and its value is, so we establish an attribute list called at PTS, which is the point search, and it equals the PC find of the geometry, the local geometry. We will call this P, and we will add our position value here, so it calculates right from the point position, and it will be affected by the maximum distance here, maximum search distance, and you see it's already calculating. Then we have the whole mesh to calculate from. All right, good so far. Let's, you see it right there, the point number. It's calculating, it's creating an actual list of the points where it could calculate the number of points around it. So, and that is, in my opinion, so far it's doing this. So if that is the point it's starting from, it's starting to calculate how many points is around it. Okay, so we established that logic. We need to take it a bit further and make it basically only calculate onto the number of points that we have selected before, which were our spawn points. So let's see how that is established. And yeah, let's do it together. So that's how you do it. You basically go into the group here. You can guess from the group, that's fine. And you will do spawn points right there. And now we're creating points, a list of points that is only for some of them, not all of them. And depending on your maximum search distance, it will create those lists of points. And it's doing it dynamically. How many points is it calculating right now? It's quite a lot. So what happens if I make this 0.01? Here you go. So let's make it 0.04. Yeah, that I like that result. And the 5 is a bit too much, right? Nah, it's fine. 8. Okay, let's just have, just so you see it, it's calculating number of points around the points of the spawn region. And this is working pretty neatly, honestly. That's amazing. Okay, so we will, so now we have just a lot of points, right? We could reduce this to 1 point only. We could do it through, for example, going to the wrangle and reducing our threshold to 0.01 maybe. This will allow us now to have how many points in here? 1. Okay, so we have a point. That's good. If I go back to the wrangle, I established this point. Let's just check which point that is. If I go into the add only, it's basically the point. Okay, let's enable the points. Good. We blasted everything but not the spawn. It should be... Alright, wait a second. Let's make a W. Let's go into the blast. Here we go. This is the point that we need. Okay, let's go space G. This should give us the point. Neat. Let's go into the wrangle. And we will establish now, one by one, that our point right here is, well, let's see the group transfer. Where is it? Here it is. That's the point that we need. Great. If I go right there, you can see it even with the normal being unstable because of its values. Let's basically add, so far we have a maximum search distance that is working, but the minimum one will do nothing. So we need a way to establish it. And in order to make it work on every point, see, the more I expand that, the more points it will calculate. The way we will establish that is a for each loop. We've done those for each loops, but now in the Vex, it will be a bit different. A for each will go into each point that we selected, and it will calculate, do some calculations on it, and will establish our minimum distance on each point. The maximum distance could be on all points, but the minimum distance could be different from one to the other. Maybe you create noise. And the reason for that is we might need it to do this. So 1 point would do the minimum distance of, let's give it a value of 0.1, and it will go this big. And one will have 0.5, and it will go this big, right? And if we're able to randomize that number and give it a seed, we will have, we'll have it go randomized like that, right, etc. It won't split here. We have to establish something else for it. But yeah, it would do this. Maybe one big, one small, one big as what, it will randomize it. And that will be our minimum search distance. And that is why we need to delete all the points that are not in the minimum search distance. Okay, let's see how that's done. Let's Control Z all this stuff. And yeah, look at how it's done. For that, we need to learn. So, hey, let's learn. Check it out. So, what we will do is we'll go through the logic of the for each. Let's just write it here. Let's read about it a little bit. So, for each, and open up a bracket. Loops over the items in an array with optional enumeration. The length of the array is determined before the first iteration. So if the array is changed during the for each, this will not be reflected in number of iteration. Okay, so far we understand that this for each can go over an array, so to speak. And where we want it to go is through the list of the PTS. So it will calculate the distance from the spawn points to the closest point. And if that distance is less than the minimum of our search, it will remove it from the possibility. Okay, that's what I said here when I put a point. And I said if the minimum search was for that particular point 0.1, then it will go that far and that far only, and the rest will be deleted, and so on and so forth. So we'll have a randomization, hopefully, of our minimum, which will create this type of stuff. Have a randomization that sparks from the actual value of the minimum search. So minimum search will have like some type of multiplication that will create a seed, basically, like we did before. So yeah, let's see how that works. So we'll delete everything here. Here we go. Let's delete all of this stuff so we have it for later. Good. So far, so good. Let's go a bit deeper into how this for each works, if I open the bracket again, and it says simple form will be a for each, then the element type. I guess element type would be the at PTS, then a value array. Let's see how that's properly done, and then we'll open a new bracket and close it, and then it blah blah blah, whatever you want to add in code here, and then yeah, okay. So let's see how that would work. Let's learn about it, people. So pause. Let's go through that. Stop asking personal questions, Sam. This is your last warning before I ban you. If you have anything in regards to what we're learning, do ask, and if not, there's no reason to be like that. Okay, so we put that in the recording. Fine. Good. So operation split each piece. Okay, so what I wanted to show you all is if I open one right there and I make you see here it says loops over the items in an array with optional enumeration. What is enumeration? And we see it's optional. So you might need it, you might not need it. This is the simple form, and this is the form with an enumeration. We used an enumeration before, but for each loop in the node version. And enumeration is nothing else than the iteration. You see it right here when we use it, if you remember. We have an iteration when we create it. I'm gonna show it to you right here. If I make a meta out of this, so I think here, create meta import node right there. And if I take that one and I look for fetch feedback, which one was it? The one that goes into the iteration number. Let's see, fetch input. Nah. Okay, wait. Let's go out, even more out, in the object view. I think we created some for our destruction. Did we know? Yeah, for the UV, I remember. So let's go there. Let's go into our HDA and let's go again. So let's go here and auto UV. Where's the auto UV? UV random right there. And so we have created an iteration, basically. We created a meta that calculates the iteration, I remember. Or was it here? Where was it? I think... yeah, here it is, 34. It calculates it immediately. That's why we... okay, fetch meta dot, it does it automatically. And that is the type of enumeration. And we hooked that value inside of the UV transform. And we've added iteration right there. The level here, this one. This is what we could use the enumeration for. So just a small explanation for me and for you, so you know what is happening. Okay, let's go one back to the object. Back to the U5, what is it called? W56. Inside of here, and then we will go to branch path finding again. And we'll start with our for each, and we'll see how that is established. And by the way, one more thing before I go. Here, if you go on the array that is shown here, and here, the array is actually the list that we created, which is the integer list at PTS. This is called an array for the for each. Okay, so far so good. Let's pause. So we'll try to understand this as much as we can. So if I open a bracket here, it tells me the length of the array is determined before the first iteration. So if the array is changed, okay, so this we read, simple form, for each, element type, value, then semicolon, and then the name of the array. I don't really understand what the element type is about and the value is about. But we'll do it regardless. He writes an integer, and gives it the name pitnum. and then gives it a semicolon right there. Then after that, we give it, of course, our array, which is in this case our wait a second, this one, array, and we'll call it at pts. We already had called it. I don't know why we have to call it again. Anyway, for now we'll just do it as it is, and then we'll open those different brackets and start writing the code. So with the tab, and then we will start with a float and call it distance, or just dist for now, because we have an attribute called distance, and we will equal that attribute to the distance variable. And we'll start opening the brackets. Here it says returns the distance between 2 points. Usage, float, distance, vector 2, A, vector 2B. Okay, so the way we will make this is first let's add our position, close the brackets, and now we will start adding the distance between the point that we selected. So first we'll start with the comma. I think there's a comma between them, right? Yeah. And then we will basically open a new bracket, and that bracket would be telling it a point to establish. Wait a second, to establish. All right, so that's the bracket that should be here. Sorry, not there. Okay, so we'll start with the point, and now we will start with 0. I'm not completely sure what's happening right now. Actually, let's read about it. It's fine. All right, so the point reads a point attribute value from a geometry. Usage, type, point, and then geometry. So which geometry we'll take in this from? The 0, the local one. String attributes name, so we need to name it. And then integer point number. Integer point number. Okay, so let's go. The first one will be the local, so 0. Then the next one will be the name of the string, which, like we did before, we'll call p. And we will get the pit num from here, from above. Pit num for our, what did it call it? I'm just gonna make it again here, point, and let's check it again. What was the last thing? Integer point number. Yeah, that's the point number, and it is an integer right there, up there. Okay, I need to sneeze. I'll be right back. Let's keep it going. For each integer point number, so basically we're getting, I'm not sure why did we call it point number, because we have num point. Then why the heck did we not, why did we call a new one, started calling it point number? And where is it getting it from? Oh man, I need to understand Vex a bit more later. But yeah, then we added the float distance. We added a new attribute. It's a float attribute, and we call it distance, and it equals distance between the point inside of the geometry and its position. This is not how you talk in Vex, I think. Completely wrong here. The attribute, what is it called? The attribute, what? The index is p, and the number of point in integer is point number, and the distance is between this and the position. That doesn't make any sense for me right now, but fine, we'll keep it like it is. Let's learn some more. We'll be right back. Just gonna check what this point number did. If I click here, well, basically we need to add a semicolon anyway. Okay. Have I wrote the code so far correctly? Here we need no space basically, and yeah, the rest is fine, right? We're getting an error here. Let's see what the error is about. We need space. Wait, not this type of space, but here. Okay, semicolon is working. All right, so we have it working now. Let's look into our details. BTS, and give me the one that it was calculating. It's fine. Okay, so it was calculating so much. Then it created the distance. Then what the heck is our point number then? Detail, X form is fine. Class, point number, point num. That is not the one, I think. Then what is integer point number that we just created? Wait a second, which one was it? PTS, that is the one that creates the distance or the search. And this is the distance, and the distance is working. However, what the heck is our PT num? Oh, dude, integer PT num. That's what we call the number of the point. So is that what we call this? PT num. I'm not quite sure. If you know, just leave it in the comments. Okay. It's getting definitely more and more complex. It doesn't matter. We will do our best to understand it. So let's do just that. Let's try our best to understand it. Let's go into. So we have a set minimum maximum search distance. Yeah, okay. Then we created our for each, which this part I don't get at all. I just don't get it. So wait, let's read about it again. For each, and it says element type, value, and the element type is an integer. The value is pt num. Then we have the array. Oh, dude, I wish I understand it, but I can't. It's beyond me right now. Fine, we will create a couple of things. One of the things that we will create, well, first we need a minimum distance. So let's do that, and let's do a maximum distance. So now our minimum distance search distance is 0.01, and our maximum search distance is 0.03. Okay. And now we will start adding an if statement inside of the for each loop that will create us two lists. One that are beyond our, so basically we're grouping in vex. That's what we're doing. So one list will be inside of the, how to say, it will be inside of the search range. So, and one will be outside of search range. So we could easily delete it. Give me a second, this thing. So, yeah, let's do those two lists. So first we'll create an if statement. Inside of the if statement, we will have, let me try to think. Our float value of the distance is greater than. So if our search distance, so now if our distance between the actual point and the search point is bigger than or is smaller than the minimum search. Okay, let's just copy it. Don't want to mess that up. Gonna copy this one. And now we'll put it here. Minimum search distance. So if our distance is smaller than the minimum search distance, then, and this one will open up now, then append, and we need something to append it to. So we need a value here. Let's create a new one. Let's call it I. So this will be our different list. And we'll give it the same name type. So instead of having point search, we'll call it FPTS, which is the final point search. This is the general point search. This is our final point search. Wait, and let's have it all together and have it beneath here. and we'll just add a semicolon. And our append will go into it right now. So we'll open the columns and we'll start with, all right, so, no, wait, let's open the column again. And here it says, adds an item to an array or string. Perfect. That's exactly what we want. We needed to put it in an array of its own. So if I go right now with the append, I say brackets at FPTS, final point number, point search, and basically add equal, wait a second, basically I will make it append, now wait a second, wait, for each loop, then it opens that bracket, then basically that bracket closes here, and something should close before it. Good. And the append, here you go, that is wrong. Append. All right, so it's not wrong, it's fine, it's just it needs more organization. So append and integer at FPTS, so it's appending it there right now. What else does it need? I'm just gonna cut it basically here. What does it need other than that? String value. Okay, that would be our point number then. ptnum, which we established up there, and I still don't get it, but I will ask for it. What the heck that means? There, I don't get it. Okay, so far so good. This should have, we just have one mistake, it seems. Let's delete that space then. So what do we have in here? We have a for each, then an integer, ptnum, then an I, okay. Then we have a bracket that opens like this. Then we have an f at distance, good, 0p, this is measuring the distance. And then we have an if statement. Okay, the if statement starts like this, at distance, good, is smaller than the minimum search distance, then append the changes, then append, good, I at final point number, correct, endpoint number, and close it. So what is the error here? Okay, there is no error. Good. We have our thing back. Let's check our values. Let's first flip our, what is it called? Where's the PTS? Here we go. So we have a PTS and FPTS. Okay, let's look at those together. That's our final point search. What it's doing is getting the points that are in the distance that are bigger than the distance. Wait, that in the distance are smaller than the minimum search distance. So only the smaller value in the minimum search distance. And it's putting them, does this make any sense? Because so we first are calculating our distance from the point itself to the last point, and we're checking if the distance between those 2 points is smaller. Yeah, if this is smaller than the minimum search distance, and if it is the case, then append it. Okay. 0.029. Okay, but what is the usage of this? Okay, let me continue in the course. We'll grab. That's what I thought. It should be bigger because it doesn't make sense otherwise. So let's make it bigger. Yeah, now it makes sense. So if the distance is bigger than the minimum search range, then append it. So only start when it is between 0.01 and 0.03. Other than that, don't append me anything. And yeah, let's see how that will work together now with everything. So let's check it out. Okay, so let's pause on.
Let's do some visualization work. So we're gonna go and do that right now. So what we would need, or where we will be working right now, is in here. I wish there was a way to get that VAX expression out and work on it on its own. So far we have set minimum and max distance, search distance. That is correct. Actually, does my mic still work? Sometimes it just doesn't work anymore. Record again. Good. We have set our minimum and max search distance right there, right? And we have set, we've absolutely removed points that are less than a minimum distance. I mean, not completely. We should just rename this to, instead of remove points, we should just group points that are less, eliminate, basically eliminate points that are less than the minimum distance. For each, good. We started with that one, and we called it PT num. Now what we need to do is visualize where the search distance is, and with that we need another for each, and we needed to color the vertex basically. Okay, so first of all, I'll just go to our add here, right there, or was it the blast? Yeah, and then we'll go space G, and just to point the actual vertice that we are grouping, this one. So we'll be right there, and then we'll go back to the for each, and now it's time to actually color some stuff. So let's do that. So we need the for each again, and we need, again, like before, an integer number, and instead of ptnum, because we use it, we will use point. And then we need the final points basically. So I at fpts right there, and then basically we'll start with the new brackets because they will determine it. We will open it and start coloring right now. So the first thing we will add is a very simple vector that will be our color. So vector will be color, or just like range color. Range color. Good. Let's put it together and make C big and this R range big. This will be equals to a set. A set is basically setting the RGB colors, which will be, if we make it green, 0, 1, 0, RGB, and a semicolon at the end. A new thing that we still need to do is something called set point attribute, which should reset an attribute. So let's see. Oh, let's see what it actually does. Set point. Let's not speak from our heads. Set point attribute. This, how do I choose one from the list? Attrib, right? We spelled that wrong. Attrib, good. Let's open the bracket and see what it does. It sets a point attribute in a geometry. It sets a point attribute in a geometry. And in this case, it will be our CD, so our color. And we will set it. All right, now first we have to read some stuff. The usage, it says integer. Yeah, what does it say? Integer geohandle. Where do we go? So geohandle is a handle to the geometry to write to. So which geometry, which will be 0 in this case. Then the name, string name, the attribute to set on the given point, which would be the color that we need to access. Then the point number. If you don't know where I'm reading here, and then I'm checking it right down there. The integer point number will be our point. The number of the point, exactly. So which number of a point that we want. Then the type. And the type will be, let me see, type would be our color. And then we need an integer set point attribute. This will be our set. All right, so we have value. Okay, let's check it out one by one. So first the geometry, then our attribute cd, then the attribute that we want to access, then which point number. Well, we have it right there. That is the point. This one. Point. That's our point number. Then we have, after that, the color, which we set, range color, sorry. Range color we set there. We set it there. Up right there. That's our value, range color. And then at the end, it will be set. And we need it between the two quotes and close it. Add a semicolon at the end and call it a day, hopefully. See if that would work. We have a mistake here for each. Where's our mistake? We have an integer. Do we need a space here? No. Integer point. What is semicolon? Sorry. In here, we need that. Okay, here we go. Now this should work. Now we are here. We have a semicolon. We need the commas here and not points and space between them. All right, and here we should have it. Here it is. That's the green vertex color on all the points that are in the range or beyond the range. So if I take this upwards, it will calculate the points. And if I take the minimum now upwards, it should, all right, let's take it to 0.25. Here we go. So now the range will be somewhere inside of here. And if we add more points, of course, if we take our threshold upwards, it will show us more points and its calculation. So I'll make the margin quite small here. And we'll see how we can randomize things later. But now we can actually visualize things, which is amazing. The next thing is aligned close enough? And is it within the right distance? We'll check that right after I have a little bathroom break. We'll be right back, people. This part, which is quite interesting, and I must add. So yeah, for example, what does this whole thing mean? Let's go and explain it. What does this align thing mean right there? And I will explain it to you. And right there, so if I make this bigger, and we see our curve, we can see it right there. It's going upwards like this or downwards, whatever works for you. What we want it to do is grow along the curve. And so if I go into our screenshot that we made, if our curve is going this way, wait, let's do this. If our curve is going this way, right, so upwards, we don't want the vines to go this way. We want it to go with it. You know, we want it to check if it is aligned with it or not. So we'll create that system now because we don't want it to grow like this while all of a sudden it's cracking up, you know. That is not how vines grow in reality. So we don't want that type of action because right now it doesn't have a direction. It's literally searching like this, right? Now it's searching what's inside of this donut, so to speak. We can put the minimum back to 0 and it will have a circle. Doesn't matter. But what we don't want it to do is grow upwards like this and then all of a sudden it's growing downwards again. Okay, let's see how that's done. It will be this search right there. Color point to visualize. We've worked on that now. It was right there. Good, so that is part of it. And now we'll check the alignment of it. Then we'll generate random value for the minimum, I think, which will be awesome. Okay, let's get into it then. So let's try to explain what we will try to do here. One way to visualize it right after that normal, let's blast some stuff. Just so we see the actual normal here. Let's view this blast. Let's take the spawn points. Let's visualize our normal and delete non-selected. So if I might go here. Wait, does it have a normal or not? points. Do we still have our normals going on here? How to view this again? Let's get the threshold a bit bigger. That's one way. Threshold, let's go something bigger again. This will take it into the blast. We have the normal here, amazing. Then we have our group, which takes the normals out. Then we transfer those normals again in, then into a normal that takes everything in back again, unless it's not a spawn point. Let's check here, right there. We have it. These are our normals from this point. But why do we have it only from one point? Okay, wait, let's blast here. Yeah, that's better. Let's go and definitely get our threshold to what it was, 0, 1. And yeah, we have the normal of that 1 point that we will delete. And just to visualize it, so now it's going this direction, right, into like the 11 o'clock. And if I view our attribute triangle right there, switch off our normals. So if it's going into the 11 o'clock, we want it to take the range. I'm going to show this to you if I make a screenshot again. That's my understanding. This is the type of logic we want to get now. And so yeah, here's the screenshot. Let's zoom in a bit. Okay, so if the normal is going this way, we want to search within this region. And we will basically delete that region here. Hi, Joker, how's it going? Let's go here. And so all of this here will be disqualified. So we will not use for our vine. Or if, then we would use this trajectory right there. Okay, so I think this is what we will do. So we'll take the equal point to it there, because if the vine is, or if the line is going this way, it's totally okay to have things in that range. So this will be okay, but here, don't touch this, right? So we'll create the logic for that. What do we need? We need the normal of the point. We need to work inside points. So let's see how that all will work. And we probably need some of the lists that we created. So we'll probably need our IPTS for point search and our FPTS for final point search. We'll work with all of those values. Let's see how it will create itself. We'll probably need a loop of some kind that checks these values. So yeah, let's get into it. So first, we're here. Let's pause the recording. I think I finally have established an understanding for what the PT num was. The integer here for the PT num is the number of points, and we just called it 1. The number of point in the loop of its iteration, because it's doing a for each, so it will do a couple of more points normally, usually. And this pitnum is basically a way to call the point number that is currently in the loop, or that is currently in the iteration. That is good to understand, because now I understand what was going on in this eliminate points that are less than the minimum distance, and it was eliminating and calculating from the point number itself. And here the distance was saying, give me the point of the geometry, and we need to access its position, and which point is the specific point of the PT num in the for each loop, and its position. So basically, we were telling it which distance to calculate from, in which distance to get to, so to speak. And this had calculated, I think, the maximum range in here. And it created a value. And that value we called distance. And now we came then afterwards and added the f distance, add distance. Okay, so now let's add the alignment. And the alignment will go with the for each again. And we will add again integer, call it point number. I'm calling it different things because we can. And the next thing is which integer list, so to speak, is it in? So which array is it in, or is it pulling from? And the array here is our PTS, at PTS, of course. Okay. Now we have and this is wrong, by the way. We need a semicolon here. Where's our semicolon? Hopefully I find it. Here we go. And we need the bigger brackets, these brackets, and yeah, enter, enter, enter. And now we will start with calling out our code, which will be at, so integer, I think in a vector at aim1, and then vector at aim2, and this one is equal to the at n, so the normal position. This one will be a bit more work. It will be the point, and now we will pull our information, basically. The first thing was to get the geometry, so it will be 0, and then it will be, let me try to think, the point needs which attribute? I think we need the n attribute here, if I'm not mistaken. The normal attribute, could be wrong though, could be the position, let's see. And then we will get our our point number right there. Point number, okay, and close it and get a semicolon. Let's see if that's correct. We'll pause, and the only wrong thing was the normal. We needed the position here, and this will be our aim, so to speak, the aim 2. Okay, so let's see what else do we need. I don't completely understand it, of course, but we'll get to that part slowly as we got into the part where we understood what the integer point here means. I think we already have a point number, so we'll just call each point number, call it a bit different, and call it back again inside of here. So each point number, and then we will, let me see, yeah, we'll create a new bracket, but because what we want, and I'll show you, is to minus the position from the position of the point it's currently looking at. So add P and put that thing together. And this should so far give us a good value that actually functions. What is the mistake here? What is happening? Why is it giving us that number or that mistake? It says here at, wait, V, why is the V a problem here? V aim2 equals point, oh wait, okay, that is wrong, right? Yeah, okay, let's see. Out and in. No, we still have a mistake here. V at aim equals point. Alright, so I know that there's a step missing here, which is the normalize point. And now we should close. So this had opened and then opened again. It closed and closed twice. Good. Let's see if this would work. Out and in again. What is going on with the V here? It doesn't want to take it. V aim 2. I aim 2 then? Still a mistake. Still not accepting anything we put here. Ah, semicolon. Excuse me. Alright, now that is what was missing. Let's get the normalize away because I want to first understand why it's not working. So open bracket again here. Good. Let's see if that would work. Yeah, we have a huge problem here. So let's see, close that one, and you basically open this one, close it, and you close it again. This should work. We still have a problem here. Okay, so back to the normalize, open a bracket. Good, this should work now. I don't know exactly why we need to normalize here. It's just because every time you use a dot product, you need to normalize it. That's what they tell us. So I really don't know what that means, what a dot product is or whatever is happening. So aim 1. So here's a big mistake in the naming. Aim A and aim B. This should be a better naming now. Aim A0, aim A1. And we basically need our PTS here. And so here we go. Aim A, which should take the aim from the normal. It's doing a 0.9 and a minus 0.09. So it's basically taking the aim value. Aim 2 is doing 0.2, which is the distance between, it's the position minus the position, P there. Now, why are we getting two values? It's beyond me. We will add that normalize as well on the at num, at the at n, and see what would happen if the value would change. We'll go here and then back inside. Aim A, the same value. Okay, I don't understand what's happening, but we'll get there. So let's try to explain the dot product. I finally got to understand it. Oh, look, we have a good visualization here. So now we have two vectors. One that is calculating the normal direction, so to speak. So we'll just delete those things. And the other one is calculating the position of the... all right, so what is it calculating again? Let's just look at it one more time. Right there. This one is calculating the points of inside of the geometry, the position of each point number. So the position of each point number and minusing it from its position. So basically we're getting I'm trying to understand it, because if you minus something from its position, and I need to understand what the position is, or the P is, so we know what the N is. CD, 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 aim, 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 P, right there. So if we minus something from its position in the X, in the Y, and in the Z, it should create a vector, so to speak, right? So if the point here is, let's say 1 in the X and Y in the Y, and 1 in the X, 1 in the Y, 1 in the Z. If you minus it through the P, through its P, it should go... let me try to visualize that, actually. Box. Let's try to visualize it a little bit, just so we get it. So this is our box, right? And space G. If I minus the... what does this do? Okay, so if I minus... okay, so if it had a 1, 1, 1 right there, see how it's going from this point up there? And so we are minusing through itself, and minusing a 1, 1, 1 will be a 0, 0, 0. And this will end up here. So basically we're creating some type of alignment, basically. And we're creating it in in 3 axes. And so what we're doing here, if I view it, click on it as well, and we have the point right there. We're creating some type of alignment with both ways. So if I go inside of our screenshot, which should be here, so this is the N, so to speak. So this should be the N, and one of them is the P. I just don't know the trajectory for sure. But what I know right now is that the dot product does nothing else than... so we'll just make a graph here so you understand what the dot product do. 0 and 0. So if we have a trajectory, say for example, the trajectory of the N is that way, and the trajectory of the P is that way or this way, the dot product between those 2 points is something that will connect them as such. I think it will connect this one to this one. And yeah, and here basically you will get the estimated number between those points. So if in the middle is 0.5, then this is 0. I don't know, 6. That will be the dot product of this trajectory. I'm sure this is used for engineering. And the same thing here. So if you go this way, it's if it will go in the minus, and if you go so against, so wait, as it goes downwards, always it goes, yeah, and if it goes downwards here, it will be in the minus. Okay, let's see what we will do with those information. So first we need to know how that is done with code, with Vex. So we'll go there. So I need to learn a little bit, and we'll be right back with you. Then let's do the dot product calculation. It's not that hard, actually. It's actually quite simple. And what we need from it, so that is the thing that I was missing. What do we need from this dot product calculation? So say we need the dot product from this to this, then we have a number, basically, because it's calculating the dot product, then we'll get a certain value of 0.1 or whatever. And this will determine if we are in that range, I think. I think that is what it is calculating for us instead of, okay, so let's go with a color. It's calculating this because it's calculating the dot product between those two. That is what I'm getting right now. And so all of those are eliminated. They're not gonna work here. Okay, so let's see if that is correct, honestly. Let's check it out. So I could be wrong. That's part of learning. So what we will do is F at alignment, and equals. So we will call it will be a float, and we'll call it alignment. Why is it a float? Because as I said here, the values between the 1 and the 0 are all point products. They're all 0.7 or 0.6 or point whatever. And so we'll use a float for that. And now we do the dot. So it will get the dot product of our vector aim A and a vector aim B. Yeah, and it should close it and give it a semicolon. All right, now this should be called alignment. So let's check on it if it worked. We have the p values, the aim A. So we have aim A0, aim A1, aim A2, and aim B0, aim B1, aim B2, and alignment right there. So if I go to the point S, so point search, our attribute that we created, and we go to our alignment, we have a alignment value of minus 0.74, which should be here somewhere, either in this trajectory or in this trajectory. But why do we need it in the minus? Why are we getting an alignment in the minus? I'm trying to think. All right, I can't find out the reason why, but we'll find out soon. Okay, let's try to visualize this, and we'll do our best, basically. So we have to add a new visualizer, which, if I remember, goes into here. And we will add a new one, and we'll call it a marker, and it will be called aim A, and it will use the attribute aim A, and it will be a point, and it will be, instead of text, it will be a vector. Aha, good. This will be our aim A, I think it's too big, so let's scale it down a little bit. So this is aim A. Good. So this is our normal trajectory. It's going this way, which is funny. It shouldn't. It had definitely not subscribed to the orient value. Okay, good. Good to know. This is our aim A that works with the all right, so we'll just close this. Good for now. Let's add a new one. Right there. And add a new one. Call it marker aim. Let's call it label aim B. And attribute aim B with a small a. And it will be a vector. It will be a point. And it will be smaller. And it will get a different color, basically. Try blue, pink maybe. Should work. Okay. So that is the trajectory of the position. That's aim B. And that is the trajectory of the normal, which is, it doesn't seem to be working. So what we will do is try to understand why that's the case. What did we forget? We must have forgot something. I will go back to the point where we created the normal. All right, so what we figured out is that this one should be on points. And instead of points here, we have guest form group. It's the same thing. And here you see it. Our aim A, and let's view only here, our aim A is going this way and our aim B is going this way, which will make our alignment calculation completely different. But first we need to favor our PTS, so point number or point search basically. Okay, and this will give us now an alignment of 0.9. So what we did is got the dot product of those 2 points, and it had given us a 0.9, which makes sense if we go here and we do the same trajectory, 1 0, right? And we say, yo, can you get me the alignment of this and this? And it would do that line, right? And we'll say, yeah, it's 0.9 actually. Good. So that's amazing. And yeah, it depends on the order of this. We could say aim B to aim A to whatever you like. So that's pretty good. We got it working. So let's go back to learning. I like that we visualize it, and now I find it finally makes a lot of sense. All right, so pause. Okay, so we need to do something now. I will duplicate this, just put it here and delete everything else. It will be our backup. Call it, just put it black. Why do we need that? Just for me. You don't need to do this. So let's check this out, everybody. We have a float, minimum search distance. Okay, so what we created here is this for each, right? I was just strict with the way we kept things together. So we'll just put this now with this one because it will be working right there. So, and what I will do is basically take everything inside of here, Control X that thing, and now put it in the first for each that we created with a pitnum, and basically go inside of here, enter, paste, and delete that empty thing here. So we have created our alignment, and it's not working because of each point number, which is something we need to update to ptnum. Fine, this is easily fixable. Then we have an if f alignment equals dot. We create the dot product. Then the next thing is we're gonna copy that append command because we will only need it to append once it had matched the alignment as well. Because we have this whole circle. We have this whole circle that we don't need. And we only need that what is in between. So we will only append in the final search point search if it had matched alignment as well. So yeah, let's create that code. Should be fine. Shouldn't be so hard. So we'll put that append right over here. And let's put it backwards. We're putting it here because we don't need it right now. We might need it later. So now we have an if statement, and this if statement will say, or it's currently saying, if the distance is less than the minimum search distance, then do something. But we don't want it to do that. We want it to actually do the following. We'll tell it to continue. And this would mean continue right there. And we'll add a semicolon. We'll copy this. So what we're doing right now is saying if the distance is bigger than the minimum search distance, don't do anything. And the same thing will happen here now. And we'll say if the f alignment, I think we called it that, right? F alignment is smaller, I think. Is smaller than, where's smaller? Like right there. Come on, dude. Okay, it's smaller, and now we need to add some. I mean, you can add it inside of the code. So let's just do it inside of the code. Is smaller than CHF, which will say float. What is it called? CH. What was the CH for? Wait, let's just add the. Let's open. It's called evaluate a channel. Okay, so float channel, and we'll call that float channel basically minimum alignment. So we established a new one now, and we could basically, here we go. Let's add it like we added everything else. So float, here we go, float. Let's copy, let's delete some stuff here. It will be called minimum alignment equals to, and now semicolon. And we will just call it right here then, just to keep things the same. Minimum alignment, then continue. And only when it's not, you will stop. Okay, so let's see how we can go from here. So okay, then let's go into it. So the next step is obvious, I think. So we'll just copy everything here. And we'll make a new float, and we'll call it maximum alignment instead of minimum, max, copy that value, and make a channel float out of it, call it maximum alignment right there. So we will use that right now in the next if statement, and we'll do it right inside of here. So if, let's actually copy this one, and we'll make it smaller. So if it's smaller than the maximum, then use the maximum alignment there. Let's get it. Maximum alignment. Good. Let's delete it again. Good. And then continue. And then if not, of course, append, sorry. All right, now I'm pretty much sure that we got some problems with the brackets here. So let's check what type of problem do we get. Let me just go back quite a bit into 26.4 and we'll watch it again and we'll be right back with you. Sorry. We'll go back into it. I think we don't need those. So let's delete them. And now let's see what happens. First of all, let's get the view that we need. Okay, and this one, great. And let's check. All right, so first we need our minimum and maximum. And we need to definitely give a value here. Here you go. That is what we need. It's working. It's working properly. This is the minimum. This is the maximum alignment. And it's perfect. So we need something in that trajectory right there. Yeah, and it should basically branch as such, and we have a minimum alignment and a maximum alignment of what is the maximum alignment? It goes right inside, and the minimum alignment that goes on the, yeah, that's pretty good. Amazing. We have all those calculations that are working for our favor. We have three if statements that say if the distance is bigger than the minimum search, then continue. And if the alignment is smaller than the minimum alignment, then continue. If the alignment value is bigger than the maximum alignment, then continue. Because we don't need an alignment to show if it was less than the minimum. We're not interested in that. We're also not interested in an alignment value that is bigger than the maximum alignment. Everything else should go inside, and this is what we're getting here. If it's less, no one cares if it's less than -1. We don't want that thing. We don't want to work with it. And basically, the visualize is showing us what those if statements are doing, and it's just showing us what it could be capable of. So there's still a couple of things to do to make this absolutely workable, but we'll probably continue tomorrow, honestly. For now, we'll continue one last time to finish the video, and then I can click on complete and continue, and this way I feel fulfilled for today. We have reached 3 videos, 3 episodes. That's amazing. Yeah, and tomorrow hopefully another 3. Which will give us the opportunity, by the way, to see if we have 12 videos in a week. So 2.4. What I want to keep from today is the 3 videos a day. This way will allow us to go even further from that week. Hopefully, let's see if this would work. If it works, it's amazing, of course. So yeah, pause. One thing to notice if you continue this way, you will have the minimum search distance completely broken. That is, of course, due to the fact that we didn't get this completely right. The continue here is not for the if, it's actually for the loop. So we're telling the loop if the distance is bigger than the minimum search distance, then continue the loop. And it should be if it was, wait a second, if it was smaller than the minimum search distance, then continue. And this should basically show us now, right there. If the distance between the 2 points, the 2 selected points, either from here to here or from here to there, whatever, is less than, wait a second, if the distance is less than the minimum search distance, then continue the loop. That means don't stop here, but definitely if it is bigger, if the distance is bigger than the minimum search, then stop the loop. So we're allowing the minimum search distance, if it was smaller, to be ignored, so to speak. Same thing with if the value of the minimum alignment is smaller, then ignore it. And here the same thing, ignore it, don't look into it. And this allowed us now to have this values here working pretty well. And you know, if our max search is on 1, then it will take all the points in the world. And if our minimum is more, then it will ignore everything behind it. And this is what we're getting from that output from the color. All right, so can you show what you're watching? No, if you're interested, you should definitely purchase the course. It's in the link below. If you're curious how we got into this progress so far, definitely check all the documentation on YouTube. And good thing that I was closing now. We have all the playlists on YouTube from day 0. If you're curious about their course and you want to attend it, definitely purchase their course. I fully support their course and their work. DoubleJump Academy, y'all, if you didn't check it yet, check it. If you haven't followed me on Twitch and on YouTube or whatever you're watching this from, do it, because we will continue working on this thing. And for you, my friend MRS Smith or Smith, will link you the actual playlist, and so you have an idea where that is at. And I hope the bot won't block me. No, I can send links. That's pretty cool. All right, so yeah, check day 1. And this is where we started learning, and nothing is hidden other than the course content, of course, but my experience is there and it's documented for everybody. All right, everyone, thanks for watching, and I will see you tomorrow at the same time. If you haven't subscribed yet, do it. If you haven't followed yet, do it. I appreciate it. The channel's still small. We have started 6 weeks ago, and we have reached 74, I suppose, on Twitch. 74 followers, that's pretty good. And 389 on YouTube, and 1,006 on TikTok. And yeah, it's growing. It's slow, it's humble, but we're growing, we're getting there. Like and subscribe or whatever, and leave a comment. Let me know that you exist. All right, everybody. See you next time, and bye. Have a great day. Stop streaming and stop recording.